Hi, welcome to this course. My name is Yakub. Now, in this course, we will be going through the basics of SQL. And what exactly is SQL? SQL is a structured query language that, otherwise known as SQL, is used to pull data from databases. And SQL is probably the easiest and the most widespread language because then it is applied in different tech fields. So, for instance, like software developers use SQL, and also like data scientists and analysts and even machine learning engineers use SQL. So, SQL is really, really vast. In terms of the structure of this course, the structure of this course is going to take a very interesting path. And this is basically because most of the courses I studied when I was also trying to learn SQL, um, I kind of noticed a couple of things, with these courses, and that I saw like a bit of shortcoming from my, experience while I tried to apply what I learned in the business, right? So first, programming languages need consistent practice. For you to be an expert, you need to learn the basic. You need to have access to some kind of data set that you will consistently use for practice. And then by practicing from time, you become perfect. Secondly, it's usually better to learn any programming language with real life data set, right? Because then when you learn with a very clean data set, which is, not real life data sets are quite dirty. So when you learn with a clean data set, what happens is you find it difficult to translate what you have learned to a dirty data set because then you come up with some kind of problems that you have never seen before. Also, most people that I have met, who have tried to learn SQL, and maybe some of them kind of came across some kind of stumbling block, actually have a very good knowledge of Excel. But the only problem is they have found it very difficult to learn SQL because they haven't been able to relate what they know from Excel to what they're trying to learn in SQL. So based on all these factors, this course is built to basically tackle all these area points. So first, this course, SQL will be taught using an environment called BigQuery. Because one, it's easy to access. So it's free and it's online. And Google, basically, with Google, the owner of BigQuery, have basically like put a couple of real life data set, like multiple real life data set that you can use to practice SQL. And this basically gives you a very wide range of options while you're trying to master this language, right? So, this is the first way we have tried to identify to basically make it easy to access and also provide real life data set, right? And then another thing this course brings is it also intermittently looks at different statements in SQL and tries to show you how this statement is already being done in Excel. So first we show how we perform a statement in Excel, and then what we do in the case of SQL, which is basically the equivalent. Now, this is included to make it very easy for the user who already has a very good Excel knowledge to basically translate what he has learned already in Excel to SQL, and it makes it a faster learning curve like that. So this is like, the idea of this course. Now, I would just like to, state a few things before we kickstart. Like I said, it's very important to practice, practice, practice. So use this course as a guide to introduce yourself to a lot of key statements, which is basically like a building block. And then in between the course, we will try to always come back to combine everything we have learned. So then we can build upon what we have learned. And then you can basically go ahead to also practice as well. In this section of the course, we will go through how to register for a free Google Cloud Platform account, because in this platform, we have the Google BigQuery. Now, BigQuery has a lot of real life data sets that allows, it allows you to practice different types of analysis on real life data, or, you could also learn how to write SQLs on this platform as well. So, but we'll just go down into, the steps that it needs to actually have this account. So the first step is actually searching BigQuery. So when you search BigQuery, you will see, BigQuery data analytics. You probably get something like this. And then, the whole idea is we're trying to get this 300 free credit. And then we can just go here and click. So here you have, actually this is in German, but if you were to see it in English, it's like, So here you will see like you have like try BigQuery free, and you can just click try BigQuery free, right? And so you get to this point where you have to like enter your email addresses, and so here at this point we will just enter the email address, the right email address, and then we'll already create so here we now enter our email address. And then here we are basically like selecting the country where you are locating from, and then you put your phone number, and then you agree to Google Cloud Platform Terms of Service and Terms of Service of any applicable API. And then you also, maybe you could sign up for an email update or something like this if you want to, but it's not mandatory. But also, like after you put in your number, you have to also like verify your phone number. So at this point, we will verify the phone number just to make sure it's we put the right phone number there. So on then your phone you get like some codes, then you basically just enter. And then you can continue. So after continue that stage, you will be directed to this place where you can basically just add your business name if you have one. So you could just go ahead and add your business name, your name, and your address, and all these kind of things, and just complete the form down the line. And then you have, okay, so I didn't enter the business name, so yeah, so basically I selected the option of paying with card. um, entering credit card details, they wouldn't charge you. They will just need you to put it there. And then you have access to the account for like your free trial. So, and then when you get to this, it's basically just asking some free, questions, and it's asks you, is it a startup, and all this kind of, little questions. So I will just basically select the personal project in this case. And then they're asking like, what brought, me to, Google. So I could just put like, just basically to learn specific about products and services. And then you could just basically select, what you like here. Basically, they're asking like, what are you interested in Google Cloud? And so Google Cloud is a very strong platform where you can do like data analytics, you could do machine learning and all this kind of things. So yeah, you could just basically go ahead and select whatever you like. And then they ask like, what is your role? I mean, I just put academic educator basically. So so basically when I've basically gone ahead to do the registration, and now I have like access to the environment. In this section, basically we will go through just a little bit around the environment. We wouldn't really do so much, but the whole idea is just to play with the environment and get used to the environment. And yeah, so let's just do it. So yeah, you see like here you have like a lot of maybe like they have a lot of product that is available for for Google Cloud platform. And in this section, you could see like some of these products are already pinned. Actually, we have more products here, but then we have decided, I mean, it's like on a default, it's already pinned to like the most like used part of it. So, and this is where we're actually coming, the big query. But in between, we could also see like we have like different projects. You have like default, my first project. You could also come here and create a new project, and every project you create has like a project ID and all this kind of things. We won't go too much into the details of the cloud platform itself, because then we are much more interested in SQL. And so basically we can just go straight to BigQuery now. Now, like, because there is a new version at the time of this recording that, basically we kind of try to give you a quick guide across the new version and what the new features are. But ultimately, we wouldn't really place so much concern on that. Here you see like this is like like in BigQuery, the store the data set in folders. So this is like a folder basically, and so basically you can expand it, but this folder at the moment doesn't have any data set at all. So we just basically we don't have anything to do with it. I mean, all these other parts you do not need for now. I mean, maybe you could need at some point, like for instance, this is just data transfers, and also like this is schedule queries. But I mean, for our level, we don't really need for data transfer. You're just trying to connect with maybe an API, something like this. But for now, we do not need this. So here we are also looking at schedule queries. Schedule queries is when you write a query that basically you want to always like update. I mean, get the latest version of it, then you use a short schedule query for that. And then here we could just start a new project, just so that we have a new project. So here we just come and try we don't have any organization here, so basically we can just create, right? And then we have our new project, right? And then from here we have like 2 projects. So this is the new project. This is project, my project 94677. I mean, it could be anything in your side as well. So yeah, I think this is like the basic environment of BigQuery. In this section of the course, we will add the public data set that we'll use for the rest of the course. So here we will just basically, we can see like we have the Explorer part of the environment, and then we can just come over and click the add data. So we add, and then we try to explore. I mean, we could basically, let me just put it like this, we could basically like do 3 things. Maybe we could search for a project, or we could maybe enter a project name, or maybe we could explore public data sets, or maybe we could, add maybe an XML data source. So in this case, if we're adding an XML data source, we're basically like, importing something into the Google Cloud platform. But I mean, we wouldn't be doing that. We'll just go for the public data sets. Now, when we look at the public data sets, we can see like we have a lot of data sets here. And most of these data sets are like, real life data sets. And they're not just the data sets that's been updated daily. So you can see a lot of, options here. You can see the COVID-19 cases in Italy and, COVID-19 open data, public forest. You could even see some cryptocurrency, Dogecoin, cryptocurrency, Ethereum, global health, and all this kind of, great information here. So we could just basically go ahead and decide to take one of the data sets, and then we can use this data set already to do like our use case. I mean, we use it for our practice. So I think I will maybe go with the London crime data set. And so basically in the London crime data set, we could see like, we could see some details about the data set and when it was last updated, the kind of the category, the source where the data was being pulled, and how often is the data being, updated. It's saying annually, but this is over a year as at the time of the recording. And then it's basically saying like it has a key, and just giving you a little bit of overview. And then it tells you a bit of the samples, give you a bit of like statistics, so you have an idea of what the stats are. And then you can already say, okay, I want to view the data set, right? So, yes. So the good thing now is we have like the full data set here. So you have all the public data sets has come here. So regardless of which of the ones that we actually selected, I mean, we selected the London crime, but we have all the data sets here, which means that we can now go ahead and try to play with all the data sets. We will look at actually how to get the data set from, the folder. So like I initially said, this is like the folder. The Google Cloud, Google basically stores the data sets in form of folders. So you have like different folders or arrangement basically. So from here, you see like the BigQuery public data folder. And then when you, drill down, you see like, another set of folders. And then you can also drill down, then you see the data set itself. So when you basically are looking for a certain, data set, you can basically like, go through a kind of like alphabetical arrangement. And now we're looking for the London crime data set. So we will go ahead and just scroll down, right? Till we get to the L. And then here we get to the L. So, I mean, here it's already open, but like normally you can, like expand and then you have a data set. But in some cases, you have more than one data set. And so in London bicycles, for instance, you have cycle hire and then you have cycle stations. But in this class, for the beginning part of this class, we will be using the London crime data set. And then we will just basically try to pull the data set by expanding and then clicking the data set itself. Now, when you click the data set, you have like, you have like a breakdown of the data set. So in the breakdown of the data set, you can see the type of, the fields, the different fields that is available in the data set. As in, like you have the different type of fields, and then you have the type, and then you and the type of the field. So basically, this for each field name you have the type. So for the ISO code, you have like string. For major category, you have string. For minor category, you have string. For value, you have this. This is going to be an integer. And then also they're saying like if it's nullable or not. So if it's nullable, then you can have some kind of null value. But if it's not nullable, then you can never have a null value. So it's just a matter of how the data is updated, right? So, and then you could go to the detail section where you get to get a bit of description of the data itself, how big the data is. It's like 1.19 gig, and when the data set was created, and when the data set was last modified, and when the data will expire. And here they said like it's never gonna expire. Now, to get a feel of the data, you could preview the data. And then immediately you preview the data, you can see like, you can see all the rows that we saw in the schema phase. You see all the, the features, basically the field. So you see like, like the row, the borough, the ISO code, the major category, the minor category, and all this kind of, just to give you a little bit of idea of what we're doing, right? And then, when you have your data set, you could just go ahead and do your query from here. And then you could run your first query. In this section, we'll talk about select. So the idea is to just give you an indication of what select is from an Excel perspective. So what select statement does from an Excel perspective. Now, assuming this is your data set, like, so when you maybe you just need, you need certain fields. So basically you have different fields, right? And maybe you do not need all the fields. Maybe you just need a certain field, right? So what exactly does select do? Select basically is just to select the fields that you need. So assuming you need these fields only, so you need the order number, the order date, the ship date. You do not need the customer ID. Maybe you need the product ID, right? And then you need maybe the quantity, for instance. So now, what select basically does is just say, it's just like saying it's selecting these very fields that you need, and then it's just coming to paste you the results. So basically, you only see the fields that you want. So here you only want to see the order ID, the order date, the ship date, the product ID, and then the quantity. You do not get all the remaining fields. Now, this is very, very useful because like it's useful to be very specific in SQL, right? Because also very much like Google Sheet or the Excel sheet, the more the cells that you put your data, the more heavy the file is, right? So it's also the same in SQL, that the more cells that you're selecting, the bigger that the result of the query is going to be. And this also means like the more time you will spend to download the data, and in some cases, the more money your company will pay, right? But if you do not need the data, then there's no need to draw it. So basically, that's why select is very, very good and powerful. And you can already use it to do your analysis by just being very, very specific. Now, that is just one part of select, right? Also, you also can use select to maybe do some calculation. So for instance, now you want to do like maybe for every quantity you would like to multiply, you could also like use select to, after selecting the columns, you could also maybe like put an extra column that is just multiplying, right? And then you say like, or maybe for instance, now you just basically make reference to this column, right? And then you just multiply all the column by, by 2, right? So in this case, this is the same way. Select could also be used to do some kind of, analysis like this. So I'm just putting this here just so it makes it easier to understand what, for people who are basically much more used to the Google Sheet Excel, to basically understand exactly what this function is doing, right? In this section, we'll be talking about the select function. The select function is one of the most used functions in SQL. In fact, for some users, they use a select function at least once in every query. It's also possible to have more than one select function applied in a query. I mean, people use like 5, 6, or even more than that in some cases. So we will just deep dive into the use case. Now, I will like if you could probably go into your public dataset folder, and then we could select one of the datasets. So for this course, we will select the Medicare folder, and then we could just basically go ahead and select from the Medicare folder. We could just select this physician and order supplies 2014. So in this, we have like the schema, the details, and then the preview of the table. And then we can put a query. We could click the query button, and then we see a sample of a data set on the left, and then the actual the actual query on the right. Now, to write this select function, the select function takes a structure of select and then a from. So for every select function, there's usually a from. It's possible to select without using a from, but in most cases you're using a from. Because then what select does is it takes what you want to select, and then it takes it from a certain table. So it's just more of like you have a shelf of different fruits, and then you decide to select a certain type of fruit from the shelf. So this is the same way select works. But in this case, what select does is actually select the futures. So you have like different futures that is represented in different columns of the data set. So for instance, this MPPS provider street is a future. And then the MPPS provider street 2 is another future. And this is also another future, right? Or another field, basically. So to select, you have to put the select, and then you write the name of the field that you would like to see. You could put the field, maybe you would like to see the provider type, and then you would like to see the place of service. So then you put a comma. So you select the first one that you'd like to see, and then you put a comma to represent that you're putting a new field. And then you put another comma and say we would like to have this HC PCS underscore code. And then you put another comma for another case. And then maybe we just would like to add just one more row, and then we have a line. Now, we have decided to select all these fields. So the provider type, the place of service, the HCPS PCS code, line, S service count. We've decided to select all this. However, we want to select this from the tables called the physician and other supply. So then we will go to the other line and we'll say from. And then in this case, we have to put the location of the table. So what folder is the table? So here we will start from the BigQuery. So we say the BigQuery. It's in this folder, right? And then inside this folder, you can see this data set in the Medicare folder. So we add Medicare. And then the last part of the folder is the physician. So here, when we run this, then we can run, basically. Then when we run the query, it basically brings us the answer. And then you will see, like, from a full data set, a data set that had like multiple columns, so basically it's just selected the columns you would like to see. So this is how the select function works. The select function, like we have them, allows you to select the features that you. So what we already know is we can select different columns from a data set using the select function, right? However, at times we do not, when we pull the data, we can see like it comes with the names of the columns. But maybe we do not want to name this column. Maybe we want to rename the column. So in this case, when we use the select function, we will add an extra function called the as function. And then in this case, we will, for every column we would like to rename, then we put an as function to it and put the name, just like this. So this is provider type, but maybe we would like to call it provider. So we put it as provider. And this is the place of service, but maybe we would like to call it department. So so we put an as, and then we can call it department. And also this is HCPCS code, but maybe we would like to call it code. So we put it as, and then we call it code. So, and we have the line of service count, but here maybe we would like to call it the count. So we put it as count. And then we run. So here you notice like the name of the column has basically changed based on what we want and not based on what is already in the data set. This is another very important point in using the select function. Also, another way to use the as function, you could decide to remove the as actually and just put a space, and then you would achieve the same thing as using the as function. So here, when we run the query, it basically provides us the same query with the new names of the columns, just as though we just as if we basically had put the as function. In this class, we will take a different, topic in the line of select. Here we could basically look at how we can do some kind of calculations. We can do some additional calculation using the select function. So assuming we would like to combine two different two different fields, so basically we'd like to do some kind of combination. So in this case, we can already do the calculation using the select function already. So, and how do we do this? So basically, if maybe we would like to add an extra row, and in this extra row, we would like to calculate an extra column, In this extra column, we would like to calculate the addition of this Benny unique count and then the Benny day service count. So in this case, we could put another comma, and then we'll say Benny underscore day service count plus Benny underscore unique service count. And in this case, we could decide to go ahead and run. And then when we run, we can see like it already provides the addition as a field named F0 underscore. But this field is a random name. This is because we did not assign any name to this field. So what we do in this case now is we will assign a name to the field, and we can call this addition, for instance. So basically note that it's just a similar way as we have done with the previous columns, where we basically said like we put the name from the table, and then we put a space, and then we put the name we'd like to see. And then we put the name from the table, and then we put a space, and then we put the name we'd like to see. So very much like that, we put the addition based on the table names, and then we put a space and then we put the name we'd like to see. So by the time we run the query now, we see like we have the same addition as what we had in the previous section, but now with a name on it. So this is how we do the addition in SQL. Also, we could decide to do maybe some kind of multiplication or division. It's very, very similar pattern. So here we could just take this same field and do a subtraction. Name this subtraction, and then we do a multiplication, right? This is a multiplication, and then we name it multiplication. And then this is a division, just like, when we call it a division. And then also we could build up any formulas as much as we want, right? So we do not have to restrict ourselves. Assuming we would like to find the percentage of, the service count from the, unique count, then we could come and even say like times 100 with the numerator, right? And then divided by the denominator. So we could call this percentage, for instance. And when we run the query, we will get now new extra columns that is based on the mathematical principle that we have applied. So here we could see that we have the code, we have the count, we have the addition, we have the subtraction, we have the multiplication, we have the division, and then we have the percentage, which is basically based on these two fields, right? Now, another thing which is very important that we can see that is happening here is we could see like the division, especially in the case of the division, we have so many, um, you know, um, I will call this like decimal places. And then it doesn't really look so good, right? So to correct this, we could just basically put like a round. We basically put a round function. So here we will put a round and just put it around the calculation part. So if we put a round like this, then we get a whole number, right? But then if we put a round in the second case, we can just put like a comma and we put 2. So what exactly have I done here? I put the round across the function in terms, across the computation, and then I put a comma in the same bracket and put 2. So this means that it will have a 2 decimal place when it does the computation. So also just to have a little view of what is the day and what the fields we're actually doing the calculation, I will just add this to the columns as well. So when we run these queries now, what do we have? So here now we have our final answer. We could see now that the division and the percentage, basically take to what we have defined. So for the division, we said we like to see it to we're rounding up to 2 decimal places basically. So we put the formula in the round, function, and then we do it to 2 decimal places, and then this is, for instance, this is like 2 decimal places. But then in the percentage part, we didn't indicate the number of decimal places, which basically mean that we would like to have it to the whole number, to the nearest whole number, and then we can see it here, right? So this is the case, and this is what our new data set is, right? So here, this is this is like another way to use the select function, particularly in the case of a calculation. So how do we use the select function to compute some calculation? However, in this class, we'll be looking at how can we select, in a dynamic kind of way using the select function. So first, we had initially looked at how to select fields from using the select function. However, it's also possible to select all fields in a very, very effective way. So we could just use the asterisk sign. The asterisk sign, when we select the asterisk sign, it means that we are trying to select all fields. So in this case, we get back every field that is provided in the initial data set. So when we run it here, it takes a while because now we have to get all the fields. And so it takes much more data to actually pull. It takes a lot of more computation and also like downloading of data to get all the data set in this case. So here now we have our data set. And here we have all the columns that is in the initial data set. And this is because we have used the star. Also, we could also combine select star with maybe a calculation, for instance, or another function. Now, another function, the rest of the function we'll discuss in future, but we could easily combine it with a calculation. So assuming we would like to know the average Medicare payment plus, maybe the average submitted charge amount. So here now, one thing we could do here is put a plus and then put this here. So what have I done? So in this case, I did the select star and then I added a new column and then I did the computation that I wanted. And now I could put like addition here. So now initially before running the query, we could see like the last column is the average Medicare standard. And then when we run the query now, so here now we could see the data set is all back and then we have a new column. So a new column that basically adds up these two columns. So here, these two columns is added to form this new column. So here you have all the data sets and then you have the added column. So this is how we use the select function. We will basically look at a new function. And this function is basically a very simple one. It is called the limit function. Now, the limit function is kind of a function that allows you to just have a feel of the data set. So for instance, you would like to see a certain number of rows in a data set, but not all the number of rows. So basically, like I will say, here you have the field that is coming vertically, and then you have the rows that is coming like, horizontally. Now, if we would like to see only the first 5, not in any order, then you could use a limit. So here you have like a query that selects all and does an additional computation. But if you have all the data set coming out and it's so, it takes a while to come out because it's so huge and stuff like this. But if maybe then you just want to see only the first 5. And in this case, you write the query as it is, right, based on what you'd like to see. And then you just add a limit function to it. So you limit, and then you put the number of rows you'd like to see. So in this case, we'd like to see a 6 number of rows, and then we run the query. So when we run the query now, we could see like it just brings the first 6 rows. And this is how, not necessarily the first 6 rows, but basically like, like this, like 6 rows, basically like that gives you a feel of the data set. So this is the use of the limit function. In this class, we basically will look at different cases as well of maybe like where, for instance. The where state, which we use to filter, the data set, right? So we do not want to see all the data set because maybe we just are kind of like interested in a certain part of the data set. So now looking at this data set, which is basically the sample superstore sales data, which is a very popular data set on the internet. Now, if we would maybe like to, filter on this data set, for instance, now, just exactly the same way the where statement does, we could basically, using Google Sheet, we could just come here and say, okay, so we only want to see data set for, customers that are, the segment of customers that are, maybe home office, for instance. So what we do here is we just filter and we select only home office. Now, this is exactly what where does, right? So for instance, before we did this, now when we did this, now we have like 1,784 rows. Now, if we were to relax this, now we have like, when we select all this row, now you see like we have like 9,995 rows. Now, we don't really need all these 995 rows because maybe our analysis doesn't really get up to this point. I mean, we're not interested in this point of the analysis, but what we just want to see is the home office customers. And then in this situation, then we already have what we want. And then we have fewer rows, which also translates into fewer size, more efficient query, which basically runs very fast because you have fewer rows. And, like also you do not get the rubbish data that you do not need, because then in this case, this is not part of your analysis, right? So also you can, like in the case of where function, you could also combine two different fields where basically using the AND function. So if you're using the AND function, maybe you want to check for home office staffs, and then you want to check for maybe sales, where the sales is above a certain limit, for instance. So you could come here and put a filter condition, just like, we will do in analysis, in Excel. And then we could say, we want to see like when cases, we only want to see for cases where the sales is above maybe 50, for instance. So when we run this, we can see like this filtering basically affects like home office, and it basically affects the sales data. At the same time, it basically looks at the two fields, and for cases where the two fields is basically meeting the requirement, the threshold, then it is revealing us the data. And then when we basically look at this data, we have even a much more specific 906 rows data, which is very, very much specific to our use case. Now, like we said, like filtering is very, very important. Also, like one of the ways that we filter as well is maybe we want to see a couple of data set, like we want to see a couple of categories. For instance, in the city, maybe we have a certain number of cities we would like to see. And when we want to do this now, maybe we just want to filter on like, a couple of cities, and then maybe we just come here and we select the cities we want, right? So in this case, this is almost like the in function that we will also discuss in the where area. And also we have something that we call the like function, right? In the like function, we're basically like trying to, predict the structure of the category that we want to select, right? So in this case, maybe we write a like statement that is basically like trying to, read text, or maybe a certain field in the city would start with maybe L, for instance, or maybe P, for instance. So when we put this now, you see, I think there's a mistake here. So, okay, it seems like we already deselected it. So when we put the P here now, we see only cases where basically like the city is starting with a P, right? So this is also possible with SQL when we use the like function. So in the like function, we can select only, maybe a certain pattern, right? So if it's starting with a P, or it's ending with an A, or it is, like containing. So you see cases where it's starting with an A here, but if it's going to end with an A, then you see only cases that it ends with an A here, right? So, and also maybe we might want to see cases that maybe has an EST in the middle, for instance, so that contains an EST, right? Maybe in part of the name. So here you see like EST, which is Western, Rochester, Manchester, and all these kind of areas. So all this is possible using the like function. Now, all this function we will look at in the where section of the SQL course. I just wanted to let you see that, the similarity between SQL and Excel. So if you have an idea of how to use Excel, looking at the where function. The where function is to rows what the select function is to columns. So in the select function, we could have a data set that has like 50 columns, but maybe we only need just 2 columns. So we use the select function to select the exact columns we want. However, in the row column, in the where function, we use the where function to select the exact rows that we want to see. So I will show you an example what I am saying. So first, we pick out of the BigQuery public data set, we decide to pick the crime folder. So basically the Chicago crime. When we look at this data set, we can see that it has a couple of, fields. And then when we look at the details, we can see that this data set has like 7 million rows. Now, if we were to write a query and we select maybe a certain number of columns, what happens is it returns all the 7 million rows. But in the real sense, we do not need the 7 million rows. Maybe we need just a section of it. Part of what we could need in this data set, in this crime data set, maybe we only want to see the crimes that happened in the year 2015. And for this reason, we don't have to, draw the 7 million rows. So in this case, we use the where function to basically limit the data set to exactly what we want to see, and then exclude whatever we don't want to see. So how do we do this? So from the data set, we could just click the query button, and then immediately we have a select. So basically we could decide to select star if we want to see all the fields, and then we could decide to run the query. But if we were to run this query as it is, so basically we see like it's selecting star from the data set. But if we were to run this query the way it is at the moment, it will return 7 million rows. But then we only need to see the data set for 2015. So because of that, we can include the where function. So the where function basically limits the data set to only 2015. So we say where year, for instance, year is one field. So we are selecting all the columns from the data set where year is equal to 2015. Now, immediately we do this, if we were to run the data set like this, then we get all the data sets back. We get the data set back only for cases where the year is equal to 2015. So it reduces the number of rows from 7 million to 264,000 cases, which helps us to narrow down our data set. In the previous case, we could see like the preview of the data set shows like it has like 7 million rows, but for the 2015 cases, we have 264 rows. So basically we could use the equal to basically limit the particular rows that we want to see. So we want to see the rows that have the year 2015, for instance. Now, assuming we only want to see for like, we only want to see the cases of arrest. Also, we could come and say where arrest is equal to true. So in this case, if we were to run the whole data set, then it gives us only cases where the arrest is equal to true. However, in this case, maybe we just want to return only the unique ID, the unique key, and the case number. So we just go and say the unique key and the case number. So when we run it now, so here, what do we see? We have exactly the case for the unique key and then the case number. Only for cases where arrest is equal to true. So these methods help us to increase the speed of our queries, because for instance, we limit the number of data that it's going to pull. So when we select fewer rows, when we select fewer columns, which is fields, we can reduce the size of the data because we have fewer columns. And then also when we limit the number of rows to the ones that is specific to our interest, then also we can help to reduce the number of the size of the data that we are pulling as well. So this is the first case. In the next class, I will show you much more use case for the where statement. So here we're just basically looking at the first case where we can just say it's equal to. In this class, we'll be looking at how to, build upon what we already know about the where function. Now, in the where function, in the previous class, we were talking about how to select, maybe you filter from just one feature or one field, right? So maybe you just want to see the data set for 2016 alone. However, in the real life cases, most of the time you want to filter by not just one row, or maybe even not just one field. Maybe you want to filter by a couple of cases, and maybe, for instance, you want to filter by maybe the major category. You want to see a certain major category for a certain bureau for a certain year, for instance. So in this case, the filter case becomes much more complex. Now, in this class, we'll be looking at how to model this type of case, this type of complex scenario, by understanding a little bit of how the where function actually works. Now, the where function is a function that basically it's trying to find the true cases, right? So it's looking at the true cases, and so basically you have to write the your query in a way that it pops what you want to become the truth, right? So for instance, if you want to do maybe for instance, maybe you have two cases that you would like to see, for instance, that these two cases must be met before, for the data set to show. So for instance, you like to see the year 2016 data for the Borough of City of London, for instance. Now, in this case, you want to see only cases where it's 2016 and Borough. So you when you even say it, you say that it's so basically you're looking for the data set for 2016 and the City of Borough. So it's the data set for City of Borough and that of 2016. So basically, then it already tells you what are you going to use. You use an AND. Now, this is where exactly I'm coming. So here you have two logical statements, which is and or. So for the AND case, you're looking for cases where you only select, instances where, like I've just discussed, instances where the two cases are met. So for instance, you have the City of London and the year 2016, right? But in the second case, maybe for instance, you like to have one case or the other. So for instance, you can decide that you want to see the data set for the City of London, right? However, or maybe the data set for 2016. So maybe either of the cases. And in this type of situation, you use an or. Another very good place to use an or is maybe if you want to see the data set for year 2016 or 2011, right? So in this case, you could use an or. Although there are some other ways to do this, but you could already use an or. So in this class, we just basically look at these examples of and or. So for the and case, we say, for instance, we want to see a Borough of City of London data, the part of the data set that is having this Borough of City of London, or maybe we could even select a different city. So because it seems like the City of London is quite big in a data set. Okay. So, or maybe we could even go to say we want to see a major category of theft and handling, right? So here you have the major category of theft and handling for 2016. So where the year is equal to 2016. Now, notice how I put this part of the where function in quotes, and here I'm basically using the year. So basically, this is because of the data type, right? So the data type of the major category, if you look at the schema again, is a string. Now, when you are putting strings in your where clause, then you put them in a quote. And for integers, basically, you can just write them as numbers. It's totally fine. So basically here I could run the query, and when I run the query, I will get like, the cases where the data set is theft and handling and the year 2016. Now, so this is it's a classic example of the AND case where you're trying to like combine two different filters, and you want the two different filters to satisfy the condition for it to come. So maybe also you would like to see for cases where it happened in the month of November, for instance. So maybe you want to see the major category of theft and handling for the year 2016, November, basically November 2016. So what you have here is you have the month must be November, and then the year must be 2016, and then the major category must be theft and handling. So in this case, you combine all the cases you want to see. So you must have all these cases for it to be successful. So you have the AND, another AND case where you put in the month, right? And then you say equal to 11, which is like representing November here. So when you run the query, you will notice that the query basically returns only instances where you have theft and handling for major category, and then you have the year 2016, the month November. So this is like the like the use case of the AND. So you basically combine a couple of cases that you want to see, and then you just AND them basically. Now, in the case of the OR, for OR, we will be looking at, like how can we use the OR? So, I mean, the OR is just basically like having a case to satisfy either of the cases, right? So if either of the cases is satisfied, then the query will, bring out the result. So it's not going to be a hard rule. It's going to be flexible by allowing either of the case to go through. So basically you could have like, you want to see data set for the year 2000 and for instance, you want to see year 2016 and or basically, or if the data set is also year 2015, for instance. So maybe you're flexible enough, you want to see either of the cases, right? So here you just put an or. So it's either year 2016 or year 2015. So here you have like two cases where you have it's 2016 or 2015. I mean, also, it's also possible, like you see from here, I'm basically combining the same field, which is basically year. I'm using the same field to filter. It's also possible to like, to basically like, use two different fields. So for instance, you could want to see the data set for 2016 or all the data set for major category, maybe like the minor category being harassment, for instance. So here you see like it's kind of having different categories, but maybe here what you want to see is either of the two. So maybe you want to see harassment or the 2016 data set. So here you put the name of the minor category you want to see, and then you put an or. So in this case, what we get back is a query that satisfies either of the condition, basically. So here you see like it's either one of the two satisfies. So for here you see like both satisfies. Here only minor category satisfies, and then you basically like drill down. So when harassment is not the case, but it must be 2016 here. So from here down, you see like 2016 data set. We will go a little bit deeper in the use of the where function. So initially we're talking about just a single case of using the where function. However, in this class, we'll be much more specific. Basically, we channel this to be much more granular to multiple use cases at the same time. So for instance, with the crime data, maybe we work in working in a certain law enforcement agency, and I've been told to get the data set for only arrest in 2015. Now, previously we only talked about how to get this for how to get certain where clauses for just one condition. But in this case, we want to look at two conditions. So 2015 data set for cases where arrest is also equal to 2. So in this case, what we do is we put the where statement for arrest equal to true and year equal to 2015. So here you have the same cases. So basically it combines. So you do not see cases where where the year is equal to 2016 or where the arrest is false. So we could just add the arrest future, so then we can double check in this case, and then the year future as well. So when we run this statement, we'll notice that for this case, we get the true. For all cases, it's for the arrest and the year is true, and it's 2015. So we do not see cases where one of this is false or one of this is not 2015. So this is the first case, the AND statement. So the AND statement is a condition that basically tries to satisfy all the conditions that have been placed. So assuming we want to combine another case to this, so maybe we want to see a domestic case, 2015 data where it is arrest and it's a domestic case. So we already satisfied the year 2015 and we already satisfied the arrest where it is true. And then we want to satisfy the case where it is domestic as well. So we say this is domestic is equal to true as well. So in this case, what we get is we see arrest is equal to true, domestic is equal to true, and then the year 2015 is equal to true. So we can even take this and even put this to be much more clear. So we have the arrest and domestic equal to true, and then we have the year is equal to 2015. So we could also include the domestic in this case in the select statement so that we can double check. And so when we run the queries, what happens? Next, we see only cases where arrest is equal to true, year is equal to 2015, and then domestic is equal to true. So basically, this also reduces our data set. So we started from a data set of 7 million. And when we selected 2015 data set, we had like 200,000. And then we have like 8,000 rows basically. So in this case, it narrows down the search. It basically makes it much more specific by using the AND statement. Now we have another statement which is basically called the OR statement. So the OR statement is different, it's a bit different from the AND statement. So in the OR statement, we basically are trying to choose between two conditions. So we release only, the data set shows us only the cases where one of the conditions is satisfied. So for instance, if we are trying to get cases where arrest is either true or domestic is true. So in this case, we basically just put OR here. And then when we run the data set, what do we get? So we get for cases where, so when we run the data set, we get cases where arrest is true or domestic is true. So you can see, or maybe it's also possible that both cases could be true as well. So basically here you see like arrest is true, domestic is false. And when you come here, you see arrest is false and domestic is true. And maybe we can even see some cases where both of them are true as well. So this is the way to use the OR function. So we combine the OR function just to be able to, like, you know, put this kind of flexibility to see cases where either one of the condition is satisfied. Now, if we want to see the same data set, which is basically cases of arrest or domestic violence, for instance, for 2015. So here, we want to be flexible on arrest and domestic cases, but we are not flexible on 2015. So they tell us that we want to get all the 2000 cases where it's either arrest or domestic. So in this situation, we will make the OR statement where we are basically grouping the domestic and arrest together because we are flexible here. And then we will be less flexible on the year. So we say and year is equal to 2015. So here, what happens next is the data set that it returns will all be 2015. You wouldn't see a single case that is not 2015, but then you'll be flexible on arrest and domestic. So there will be one true or both will be true. But 2015 will all be 2015. You wouldn't see a single case that is outside 2015. So this is the case of how we use the OR and AND statement. The OR and AND statement. So this is an example of using the OR and AND statement. So we can combine it in different ways, right? And even if we maybe, for instance, have been told not to use, so basically we want to see all the data set except 2015, right? So we want to see the data set where the arrest is true or the domestic is true, but we want all years except 2015. Then in this case, we could already put this function here, and then we will get a data set without 2000. Now, in this class, we'll be looking at another type of where statement. I mean, it's still the same where statement, but it's just an extra, way to use the where statement. So for instance, now we basically come to a situation that we see like we have a data set. Now, for instance, this is just a service request data set from the Austin 311 folder in BigQuery. So we have this data set now, and from what we can see from the preview of the data set, we see that in some cases, we do not have the street number. Now, assuming the street number is, like really, really important, or maybe for instance, we do not have the council district code. Now, assuming this field is really important in our analysis, right? And, maybe we're trying to use the data set to add up like how many service requests was made from a council district code. What will happen is we will have these null cases, and this is going to really affect our work because we might just end up counting a lot of cases that is null, but the null do not necessarily belong to the same area. It's just basically a case where we do not have the case. So maybe we already want to remove this type of cases from our data set. So what do we do in this type of situation? So here we just basically come And we can just basically query the table as usual. And then we select the side of a data set that we want, right? So basically we select what do we would like to see. We would like to see the unique key, right? And then maybe we would like to see the complaint type, right? And here maybe we want to see the council district code. So we want to see the council district code, right? And when we run this query, now we basically have the query telling us like we're selecting the unique key, the complaint type, and the council district code from the BigQuery data set. And then we decide to limit it by 1,000 cases. So then we just have like the first 1,000 case of the data set. So when we run this data set, just to see a little bit of preview, what we notice immediately is that we have some null cases, right? And maybe we do not want to have all these type of, cases because if we were to remove the limit case, maybe for instance, now we have like a data set that is even larger, right? And maybe this data set is like going like 1 million cases. And, many of the data set is just having council district code that is null. And we do not want to have this kind of case in our final data set. So what do we do? So what we can do, one little quick solution to this is put a where statement. And then we select this column, which is basically the council district code. And then say we would like to select this column at areas where the council district code is not null. So what does this do? It basically selects the whole data set and filters off any row that it finds the council district code to be null. So basically we have the unique key, the complete type, council district code for only cases where the data set has some kind of council district code. Another thing we could do is, assuming we would like to see the cases that are null. So maybe what we just do in this case is we say where council district code is null. And so it will basically run the same query, but then now it's giving us only the cases where you have null. So this is the idea of the not null, the null cases, right? So this basically helps you to also, it helps you to basically filter the data set in a very, very specific way. Also, you can combine this with the and or, where you combine a couple of filters together. This is also very possible in this case. And I think this is just the main thing that we are trying to do now. This section we'll be looking at how to use the in and not in function. Now, the in and not in function is very similar to the equal to and not equal to function that is used, that we kind of used in the previous class. However, the method of usage and the flexibility of usage is quite different. So I will give you an example. Assuming we were to select certain rows based on the location description, for instance. Now we have this data set that we have been using, the crimes data set, and we'd like to select rows where we have a sidewalk or a street or a resident, right? So in this case, we have what we would have written as where, for instance, location, description. So we want to select 3 different types of rows. So we have location description is equal to sidewalk, for instance, or location description is equal to street or location description is equal to resident. right? So in this case, we can decide to write like 3 different OR statements or 2 different OR statements just so that we can accommodate all these different instances. However, what the in statement, so when we come here, and maybe we should select the location description so then you can see the impact on the query. So then here, what do we have when we run this query, for instance? So here, what do we have is we have the location description, which basically could select rows that are resident or street, or, you know, the last case is the sidewalk. Maybe it takes a while and then we see the sidewalk, right? So basically it's selecting, you know, rows based on, it's selecting rows based on this location description, and it's selecting like, you know, 3 different instances in this data set. Now, the location, and so this query that we have written is quite long because then we have to repeat the location description a couple of times using the OR statement. And I mean, we're selecting from just one field. So the in statement allows us to write this in a much more efficient way. So what do we do if we were to write this with an in statement? So to write this with an in statement, what we just basically do is we say in, and then we open a bracket and then include all the different variations that we would like to see. So what are we trying to do here? So basically we're trying to select all these use cases, all these fields from this data set where location is in either of these cases, right? So if we run this, it will look for rows where the location is either sidewalk or street or resident. So if we were to run this query, we will get exactly what we have here. Now, I mean, the arrangement might be different because we are not restricting the arrangement for the moment, but it will still be the same data set. So basically that. And that's where you have the in function. Now, so we have the in function, and we can use the in function in, you know, different ways. Especially we use the in function especially with string characters. So if we want to see you know, different string characters and different ways, I mean, we could also use it with integers as well. So like in the case of the year, for instance, we could basically take this away now and say year, where year is in 2015, for instance, and 2016. So we want to see cases where year is either 2016 or 2015. So we wouldn't have to write year and, you know, twice and basically have the or, you know, like that. And so basically when we run this query now, we basically now see that we have the data set with 2015 and 2016. So this is the data set of 2015 and 2016. So this is a very good way to select multiple, you know, like multiple conditions in the same field without necessarily writing a very long query. Now, if you were to write the inverse of this, so the inverse is actually not in. So if we do not want to see the years, we don't want to see the data set for years where we have 2015 and 2016, then what we do here is we say where year is not in 2015 and 2016. So what do we have here? We have not in. So here, what we have here at the end of the day is we have years that is not 2015 and years that is not 2016. So this is what we have here. So, I mean, this is the application of the not in statement. So basically, we have applied it with the where statement, and I mean, we could also combine it with even the and statement, and then include the previous case, for instance. So where we can now say that we're writing a query that is selecting. Sorry, just a moment. So we have a query that is selecting we're selecting all these data sets where the year is not in 2015 or 2016, and the location description is in sidewalk, street, or resident. So by the time we run this query, we won't see the data set containing these 2 years, but we must see either of this in our data set. So here we see, like, for the years, you can never see a 2015 or 2016. And at the same time, you will see the sidewalk, street, or resident in the case of the location description. So basically, this is the final case. We basically will try to apply everything that we have learned together in terms of the where function. So in the where function, we basically learned all different types of ways to filter the database using different types of methods. So first we looked at mathematical numbers, and then we looked at in and not in. And then we looked at like and not like, basically, and also we looked at between. Now, in between that, we basically also learned like and or. So how to basically combine different types of, filtering the statements together by using and or. Now in this class, we just basically do something like a revision of everything that we have learned. So basically we combine the cases of greater than or equal to. We combine it together with the and. We use the and or to basically combine it. So first, when we look at this case, now maybe we have like this full data set here. And then we decide that we only want to print out maybe the data set for maybe, for instance, would like to only print like the case number that starts with, H, for instance. So first we say like the first condition is the case number should start with H. So we say we're looking for case numbers that start with H, right? So where it is like H. So we say H, and then we put the percentage sign. So first, in this case, it's selecting only the cases that start with H. And we also would like to put it in between, maybe like we would like to put it in between a certain period. So your certain date period. So first, maybe in between 2015 to 2016. So basically, here we just say, okay, and the date should be between, so the date between so the date between, so we copy this exactly the way it is and we put it into brackets, so because then we're working with dates. So basically we just say like we come here and we change it, so we only want data for maybe 2015. So we come here and put a 000, right? And so for between, we put the and then we just copy this and change it to 2016, right? So it should be between this and 2016. So here we also have this, but to make our queries even look better, because then this is a different condition. This is one of the conditions, and this is a different conditions. And when we put a between, it basically makes the query looks even a bit kind of messy. So maybe we could just decide to put this on a separate line, right? And and then put this into bracket, because also we're using the and symbol. So this basically, we put everything into bracket. So basically this makes the query even look even understandable. And maybe we also like to, combine another situation. Maybe we're saying like we only want to see the cases where the we only want to see for instances where the word is basically more than 10. So basically we're looking for cases, and so word is maybe more than, or maybe more than 10, for instance. So for instance, in this case, we also filter in by this. And also we'd like to combine the case also for, another case where, say we would like to combine a couple of categories. So we want to see categories like resident, and also maybe resident garage. Let's say resident and say like alley and street. So this is the ones we would like to see. So we come here and we see the location description. So if we want to see, and location description is in, we kind of went through the in. So we have the resident, which is one of the cases we'd like to see. So we combine it here. We put it into, we put it into this kind of quotation because it's a string. And then we take the alley as well, which is basically another instance that we would like to see the location description. And then also we take like a small retail store, which is like the final part where we would like to see the location description, right? So here you have like, a very complex query. It's not so complex, but it's just basically like, like combining all these things that we have learned. Or maybe just some part of it, but like combining everything together into one query, and using it to like build a certain type of using it to build a certain type of query. So basically what we expect in this case is we want to see cases where the case number is starting with a H, and then the date is between 2015 and 2016. And then also the word is more than 10, and then the location description is, within this examples. Now, so I could basically include the date because then we also have the date here. So basically we include it here so that we can, check our answer and make sure it's correct. Now, if you notice, we also used and all true because like in, this particular question, we want to see, situations where everything is happening at the same time. So we don't want to see, we don't want to put the flexibility of, either of, one particular field happening in a certain way or the other is happening in another way. So basically we have and in all cases. And so when we run this query and we come to the results, we can see exactly what we have, asked. So first, we want only case numbers that is above H, that is basically like H. So basically, in this case, you see everything is starting with a H. For all the case numbers starts with H here. And then when we look at the location description, it's basically residence or alley or small retail store. So when you come here, you only see exactly residence, small retail store or alley. And then when you come to the word, it must be more than 10. So here you can only see words that is more than 10. So for here, you could see 11, but I guess like when you go to the last page, for instance, you will see like 50. So basically, and then you could basically like try to look at the location. So also we're trying to put the range of the date, sorry. So the date range is also between 2015 to 2016. So when you look at the data set now, you can only see cases where it's 2015. And you wouldn't see cases of 2016. So because that's the upper limit. So basically that, and that is just basically the idea of using the where function to filter the data set based on what kind of analysis we're trying to perform, or the kind of data set that we're trying to get from a database. So in this class, I think like we've been able to like demonstrate how to use the where function, combining it with different types of flexible method to basically make our analysis even very much specific to our use case. Now in this class, we're basically looking at how to combine different data sets together. So when I mean combine, we are not basically like joining, but basically we are looking at how to basically like union two data sets. So for instance, here we can see that we have this Austin incident data set, And in between this Austin incident data set, this has been basically broken down into 2008 data set, 2009, 2010, 2011, and 2016. Now, assuming we would like to have this data set all together so that we could actually run an analysis together without necessarily breaking or separating any part. One of the things we could basically apply here is to use a union statement. Now, to use a union statement, let's just first look at the data set to even have a look of it. So first and foremost, one of the rules of using a union statement is that you must have the same fields similar fields, in terms of the type as well. So basically, if you would like to union two tables, you must have the same number of fields. So one of them cannot have 9 fields and the other will have 8, for instance. The arrangement of the fields is also very important. So one field cannot be basically union to a field. An integer field cannot be union to a string field, for instance. So basically, you have to either convert or basically you can only union a similar field. So when we look at the 2009 data set, we just see it's basically the same. The same in the sense that it's the same in terms of field and type when we compare it to the 2008 data set. Now, this is quite this basically means strong chance that we can actually go ahead and union the data sets together. So now we will just basically do our example so that we can already start and see how this works. So for instance, when we want to run this query, we could just click query from BigQuery here, and then so when we see this first query, we see it's saying you have a star. So we could just say select star, and then we put the from statement here just to make our query even much more beautiful. And then when we run this query, we get only the data set for 2018. Now, if we want to union it with the 2009 data set, then we just write exactly the same query down. But then in between, we have to put a union, right? So we put a union just to make sure the data set is union together. So we could put a union all. And when we put a union all, it basically brings a very, very interesting type of analysis. So then you can see. Now, when we run this query together, we have to basically take a step back because then I didn't change this to 2009. So when we put a 2009 here, what happens is we get data sets for 2008 and 2009 all combined together. So here you will see for the first row, you have 2008. But by the time we go to the last page, we have 2009. So basically the two data set has been combined together. Now, the funny part is so we could basically see that we have we have two data sets that be combined together by just the use of this union all. And this basically allows us to go ahead and do our analysis, right? Now, in some cases, we could see that. So if we were to say, we would like to see, for instance, maybe we would like to see a certain type of, maybe we would like to see a certain type of description, for instance. So basically, we want to see the distinct description that is available. So meanwhile, what we do in this case is we will just basically hide our data, our query, and basically make our query not so functional by just putting this little symbol. And so when we run this query, it's only running the top part because then we have basically commented out this part, right? By just the addition of this diagonal and star, and then star diagonal to basically close the area that we do not want to run in a query. So basically now, if we were to say we wanted to see the possible descriptions that we have in the first case, so we have the script here, we could see when we run the data set, we have different descript, and maybe we even want to even be much more specific by saying we want to see only the distinct cases, right? So the distinct cases where it's not null, for instance. So we say where the script is not null, right? is not null. So we only get cases where the descript is not null. And then when we run this query, for instance, now what do we get? So basically we come here and we get like, different cases, right? So basically we have different cases, but they only appears once. Now, this is very, very interesting. This is a very, very interesting case, right? So we could also say we want to see this query. Maybe we want to order the query, for instance, by the description such that, you arrange it alphabetically. So you have like the descript, and then you want to arrange it alphabetically. So what do is basically you say ascending. So from A down to Z, basically like that. And then you see like what we have is we have like, like it arranged in an alphabetic order, and basically like it's good, right? And then maybe we say, okay, we would like to limit this query to, only bring us the top, 10 instances, right? So in this case, what we see here is we just see like only the first A's, and then we have only 10 samples. So now similarly, we could, when we see what we have seen now here, we could see like, okay, so we have like, only just say like, the first 10 from an alphabetical description, types of description that is existing. Now also we could, basically hide this data set that gives us the top, 10 from an alphabetical order in terms of description. So we can hide this and allow this to fly. Now I'm trying to do something so then you have a better understanding of what the union is. And then when we say the same, we put the same distinct descript here, right? And then in this, instead of having like ascending, order by here, we decide to put a descending order by. And then we limit it by 10. So what do we expect to get in this query? So when we run this query, we'll see that it's almost like the opposite in terms of the arrangement of the description. So we start from maybe like we don't have Z and we don't have Y, and we don't have X, any description that starts with any of these letters. So basically we start from, W, and we basically go down to Z, V, and all these kind of things, right? So now, if we were to basically, we have on the top, we have a data set that basically has like only, description types that start with A, and then below we have the ones that start with W and V. So if we were to union these two data sets, for instance, because we can actually union these two because this is a string and also this is a string. So it's a string column to string column. And when we apply a union OR, what do we get? So basically we get like, what do we get here? So basically here, so I will just basically have a look of this and see why this is, okay. So so basically we could just maybe put this into a bracket because like it seems to be confusing, like, so when we put a union OR here, so we could see so basically now we want to union these two data sets. Now we have to basically like do a little bit of like segregation of the data because SQL is built in a type of way where we already have some arrangement order where we have to select from, we have the where, they have the order by, we have the limit. So it doesn't really expect a lot of functions to come after the limit, and so because of that we had to put it in a bracket just to make sure like the query kind of represents that this query is basically like he understands that this query basically is together and the other one below it's actually together. So when we run these two queries together, what do we get? So basically here we get like, basically we have this, we have this situation where we have like, the combination of the data set that has like a description, right? And then the data set that has the W and V description, right? So in this case, we have 20 different cases of, 10 of each data set. Now, this is very interesting, right? So this is actually very interesting because then we have exactly what we want, right? So it makes sense. Now, assuming we basically come here and then we have like the same situation, right? So basically we have the same two data sets and then we decide to union all. So basically we have the same data sets that we're unioning all. So what happens? So when we union all, we notice that we have like basically a combination of the, like the union all. Basically you have like the same thing combined in two different cases. So basically this starts again. So it takes the query, it doesn't really care, like it has seen this before, and then it just basically unions it again. So you have the 11 is going to be equal to 1, and then 2, which is abandoned bicycle, is also going to be equals to 12. So basically you have like duplicates of the same query. Now, this is what happens when you union all in any case. Now, in normal SQL, you will see that you have union all and you have union. However, because it's a big query environment, you have what they call union distinct. Now, in the union distinct, what union distinct is doing, which is very equivalent to union in many other, like many other SQLs, basically many other SQL environments. So union distinct is basically the same as union. What union distinct does is it basically excludes cases of duplicates. So for assuming we had like multiple columns here, now what it does is it basically looks at the multiple columns and it sees like it compares the multiple columns and compares it with the one in the data set below. And if it sees like there is a row that already occurred, and then it's basically like excluding it. So for instance, now we have like a data set of 2008. And then we have, assuming now we have a data set of 2009, but maybe when the data was collected, for instance, maybe in the January 1st, for instance, of 2009, they decided to mistakenly collect part of the in the 2008 data set, maybe they kind of included 2009, maybe for January, maybe the 1st of January, they had this. And also this same data occurred in 2009 data set, for instance. What happens is when you use the union distinct, it basically gives you only one, case of, the 2009 January kind of statement. So basically to avoid some kind of duplicate. So when we use this union distinct, when we run this query, what we notice here is we only have 10 rows. So because we see like this query is basically the same as this query, so it doesn't go ahead and publish like duplicates. It's just basically publishing the same data set. I mean, it's just basically publishing the data set just once, which basically allows, you to basically have only one version of the data set. Now, like I said, the union distinct is basically the same as the union in many other, data. So in many other SQL environments. So now in SQL environment, I mean, you only have like union or union or, but in the BigQuery SQL environment, you have union distinct and then union or. So just put that in the note and take it, put it in your mind while you do your analysis. But other than that, like you were good. We've seen like what the impact is. The most important about SQL is to understand the basics, to understand where to use what. And then when we combine everything together, we can build like really, really powerful queries that basically solve, very important business problems. Now, in this course is basically a combination of a lot of anonymous things to learn, right? So in this course, we'll be looking at some little tips of, things that we could use to make our, like the process of our analysis even faster. So assuming we have this data set now, so we basically have this data set and the name of this data set is maybe 311 service request. And then maybe we have to write a query. Maybe we come and we say, so basically I'm trying to query the same table. So I just come here and now say, okay, so I want to have like maybe complaint, description, right? And I want to also maybe, maybe get like the created date, for instance, right? And then I would like to get the last updated date. So here it is. I have like a data set that is like, I have a data set that is maybe, like this, where basically I'm selecting the complaint description, created date, and the last update date. And I'm selecting everything from this um, table called the service request table. Now, what happens is this is we could basically at times get to this point where we're kind of playing with this type of data set and we are not really sure like what we want to do. Maybe we're trying to still figure out, different things, and maybe we have written so many queries and we do not want to lose any one of them. So I do not want to delete this query, but I want to write another query, right? And so maybe I can write this new query down here. And maybe this new query is supposed to look for some other thing, right? Maybe I'm not yet made up my mind. Like I'm just trying to test what I'm doing, right? And so I just come and write the street name, for instance, here. And then I write the complaint description here. And then I have like the last update date. Maybe this is what I'm trying to change my mind to. So what happens here is like, because I have two different data sets, I cannot run the two together, because then you see this is already showing me like the second part doesn't make sense, right? So basically it already has a red arrow. So I might decide to blank off like the former part of a data set. So this is like, this code basically shows you how to do some of this type of little tricks. So maybe if I were to put two dashes on every row that I put two dashes on, then I automatically wipe that place out. So this query is not going to run. So it's mean like I have deactivated the query, so to say. So when I run this query now, what I do get is just the lower part, right? So you have like three columns. Now, in similar fashion, if I also come to the back of complaint description and then I put these two dashes, what it does is it deletes the third column, knowing fully that I could just come back and release it. Maybe I do not want to delete it yet, but I just want to deactivate it. So when I do this, it basically deletes the impact of the last row column. And then when you run the query, what you know is the data set goes from 3 and then it comes to 2, because the last part of the data set has been deleted anyways. So this is the case, right? So this is a little trick that people do maybe when they're still, because then when you develop your code, maybe you develop it in parts, and when you develop in parts, you maybe at times you want to keep some part of the query and you want to run some other parts of the query. Now, another very good way of deactivating a query, especially if there is a very long chunk of it. So maybe, for instance, we have another, third query that we have written here. And this time around, here is called the city instead of the street name. Now, and then, and then I discovered like, okay, so we would like to run, we have 3 queries, and then we would like to run just the last one, right? So we do not want to run the first 2 queries. So another very good way of, deselecting a query and deactivating the query is basically to put this query in some kind of envelope. Now, what do I mean by an envelope? Now, this is not a standard term, don't get me confused, but the whole idea is to put it in between a slash and an asterisk. So what do? You put a slash and then you put an asterisk, right? So when you put the star and asterisk, you notice like it seems to have deactivated all the queries, but no, this is not deactivated yet because it's still giving us an errors anyway. So then you have to replicate what you have done in the beginning at the end as well of the area where you would like to delete, right? So basically here, you could just put like a star and then a slash. So in this case, what has happened is basically it has kind of commented out from the beginning of the query till this point, and then just basically allows only this point to run. And then when you run the query, you get exactly this. So this is like, another way to maybe like comment out your queries. Now, another very good tip that you could put into use also is the way you arrange your queries. It's very important to arrange your queries in a way that it makes it easy for somebody else to read, right? So, because then at the moment we seem to be writing very simple queries, and because of that, we don't get like 100, or maybe 200 lines of code. I've seen like 500 to 1,000 lines of code, especially in BigQuery. But because we are still in the beginners level, we do not like get to this point. And so basically we could just look at like some cases where, some little tips you could put into consideration when you write a query. So for instance, when you write a query, you can just like make sure you indent your query. So for instance, if you are selecting a couple of fields, you have the unique key. So you could say unique key. So maybe, okay, you want to select city, and then you want to select unique key. So you could just do it like this, right? Like we have all done throughout this course, but this is only done because, we're just still learning the course anyways. So we could just, you could have like complaints, some complaint description, right? Some owning department, and maybe some source. And then you pull it from the 311 service request dataset, right? So here, from this dataset, but we still, for the BigQuery, we still have to put it in a kind of arrangement. So we put it in columns and we put the BigQuery there. So then it's just BigQuery. So here now we see like we have our query, and maybe we even have to select more columns. So we put status, and then we put like, maybe created date as well. So when you look at this query, it's becoming so long, and it's becoming so long that if we keep adding new columns to this query, then it becomes really, really messy, and it's very difficult for anybody to understand. So one of the best practices is to have each selection on a different line. So basically you put an equal to, so you select, and then you put an equal to. Then also you basically indent. So you have all the queries starting from like a point. So how do you indent? You put the tab key, and then you just put some kind of indentation to it. Just this thing is not going to prevent the data, or it's going to affect the performance of the query, but it's just going to, affect the readability of the query. So then it's easier for a third party to read the query, for instance. So when you, put this, you just put like an equal to, and then you notice like it's already becoming readable, right? So the person who's reading this query now understands what we're trying to do with one glance, and not necessarily trying to like overwork himself, right? So this is the idea. So you have like a new feature on a line, and then you basically also add, for every little addition you do, make sure you also put it in a line. So for instance, you were to put a where statement, you had to put like a limit statement. You do not put it on the same line. Just make sure you take it to another line, and then it's already looking really, really beautiful and really easy for someone else to understand the query. Now, this is all we are going to do in this part of the class. It's just about the tips. It's nothing more. Now, in this course is basically a combination of a lot of anonymous things to learn, right? So in this course, we'll be looking at some little tips of, things that we could use to make our, like the process of our analysis even faster. So Assuming we have this data set now, so we basically have this data set, and the name of this data set is maybe 311 service request. And then maybe we have to write a query. Maybe we come and we say, so basically I'm trying to query the same table. So I just come here and now say, okay, so I want to have like maybe complaint, description, right? And I want to also maybe maybe get like the created date, for instance, right? And then I would like to get the last updated date. So here it is. I have like a data set that is like, I have a data set that is maybe, like this, where basically I'm selecting the complaint description, created date, and the last update date. And I'm selecting everything from this table called the service request table. Now, what happens is this is we could basically at times get to this point where we're kind of playing with this type of data set, and we are not really sure like what we want to do. Maybe we're trying to still figure out different things, and maybe we have written so many queries and we do not want to lose any one of them. So I do not want to delete this query, but I want to write another query, right? And so maybe I can write this new query down here, and maybe this new query is supposed to look for some other thing, right? Maybe I'm not yet made up my mind. Like, I'm just trying to test what I'm doing, right? And so I just come and write the street name, for instance, here. And then I write the complaint description here. And then I have like the last update date. Maybe this is what I'm trying to change my mind to. So what happens here is like, because I have two different data sets, I cannot run the two together, because then you see this is already showing me like the second part doesn't make sense, right? So basically it already has a red arrow. So I might decide to blank off like the former part of a data set. So this is like, this code basically shows you how to do some of this type of little tricks. So maybe if I were to put 2 dashes on every row that I put 2 dashes on, then I automatically wipe that place out. So this query is not going to run. So it's mean like I have deactivated the query, so to say. So when I run this query now, what I do get is just the lower part, right? So you have like 3 columns. Now, in similar fashion, if I also come to the back of complaint description and then I put these 2 dashes, what it does is it deletes the 3rd column, knowing fully that I could just come back and release it. Maybe I do not want to delete it yet, but I just want to deactivate it. So when I do this, it basically deletes the impact of the last row column. And then when you run the query, what you know is the data set goes from 3 and then it comes to 2, because the last part of the data set has been deleted anyways. So this is the case, right? So this is a little trick that people do maybe when they're still, because then when you develop your code, maybe you develop it in parts, and when you develop in parts, you maybe at times you want to keep some part of the query and you want to run some other parts of the query. Now, another very good way of deactivating a query, especially if there is a very long chunk of it. So maybe, for instance, we have another, 3rd query that we have written here, and this time around, here is called the city instead of the street name. Now, and then I discovered like, okay, so we would like to run, we have 3 queries, and then we would like to run just the last one, right? So we do not want to run the first 2 queries. So another very good way of, deselecting a query and deactivating the query is basically to put this query in some kind of envelope. Now, what do I mean by an envelope? Now, this is not a standard term. Don't get me confused, but the whole idea is to put it in between a slash and an asterisk. So what do? You put a slash and then you put an asterisk, right? So when you put the star and asterisk, you notice like it seems to have deactivated all the queries. But no, this is not deactivated yet because it's still giving us an errors anyway. So then you have to replicate what you have done in the beginning at the end as well of the area where you would like to delete, right? So basically here, you could just put like a star and then a slash. So in this case, what has happened is basically it has kind of commented out from the beginning of the query till this point, and then just basically allows only this point to run. And then when you run the query, you get exactly this. So this is like, another way to maybe like comment out your queries. Now, another very good tip that you could put into use also is the way you arrange your queries. It's very important to arrange your queries in a way that it makes it easy for somebody else to read, right? So because then at the moment we seem to be writing very simple queries, and because of that, we don't get like 100, or maybe 200 lines of code. I've seen like 500 to 1,000 lines of code, especially in BigQuery. But because we are still in the beginners level, we do not like get to this point. And so basically we could just look at like some cases where, some little tips you could put into consideration when you write a query. So for instance, when you write a query, you can just like make sure you indent your query. So for instance, if you are selecting a couple of fields, you have the unique key. So you could say unique key. So maybe, okay, you want to select city and then you want to select unique key. So you could just do it like this, right? Like we have all done throughout this course, but this is only done because, we're just still learning the course anyways. So we could just, you could have like complaints, some complaint description, right? Some owning department, and maybe some source. And then you pull it from the 311 service request dataset, right? So here, from this dataset, but we still, for the BigQuery, we still have to put it in a kind of arrangement. So we put it in columns and we put the BigQuery there. So then it's just BigQuery. So here now we see like we have our query, and maybe we even have to select more columns. So we put status, and then we put like, maybe created date as well. So when you look at this query, it's becoming so long, and it's becoming so long that if we keep adding new columns to this query, then it becomes really, really messy, and it's very difficult for anybody to understand. So what one of the best practices is to have each selection on a different line. So basically you put an equal to, so you select, and then you put an equal to. Then also you basically indent. So you have all the queries starting from like a point. So how do you indent? You put the tab key, and then you just put some kind of indentation to it. Just this thing is not going to prevent the data, or it's going to affect the performance of the query, but it's just going to, affect the readability of the query. So then it's easier for a third party to read the query, for instance. So when you, put this, you just put like an equal to, and then you notice like it's already becoming readable, right? So the person who's reading this query now understands what we're trying to do with one glance, and not necessarily trying to like overwork himself, right? So this is the idea. So you have like a new feature on a line, and then you basically also add, for every little addition you do, make sure you also put it in a line. So for instance, you were to put a where statement, you had to put like a limit statement. You do not put it on the same line. Just make sure you take it to another line, and then it's already looking really, really beautiful and really easy for someone else to understand the query. Now, this is all we are going to do in this part of the class. It's just about the tips. In this class, we'll be basically looking at the order by statement. Now, what is the order by statement? We're trying to explain the order by statement by using the Excel, right? It's very much similar to how we order the sheet. Maybe we would like to order this sheet by, the date of the ship date, for instance. Now, if we want to order the sheet by the ship date, so basically we just come here and we, the same way we would come here and say, oh, we will like to, so basically we just come and say we sort the sheet by column D, right? And then we go from A to Z. It's the same way. I mean, the very same way is, you see, like here now, it's basically following the, it's kind of increasing the date. It's the same way we actually sort the SQL by the, using the order by. And you could basically sort in descending format or in ascending format, just the same way it is in, in Excel. So also the same thing here, you see, like it's basically going from the highest to the lowest, right? And so you can also have the descending order by. So this is just also another case where we just basically explain what we are doing in SQL by Excel, to let us know that there's nothing really special that we do in SQL. I mean, it's just basically doing it in a much more efficient way and a much more structured way. You're welcome to this class once again. In this class, we'll be looking at how to use the order by statement. Now, we already come and we have, selected the first data set in the BigQuery public data set, right? So this data set is located under the Austin 311 file and has the name of 311 service request as the name of the data set. Now, when we look into the schema, we can see that the data set basically has different descriptions, it has a detail, and you can preview this data set to, basically see like what is this data set like. Now, you might be told to do some kind of analysis where you are supposed to, give some kind of arrangement. So if you see, you could see like the transaction has, it seems like some kind of service request that basically was created on a certain date and was updated on a certain date and was like closed on a certain date or something like this. Now, maybe you want to give some kind of like, you want to report this data set, but you basically have to report it in a chronological order, right? And so here, maybe what you have to do is just find a way to order this data set and just present it. Similar to what you will do on Excel to sort the sheet by, sorting the whole sheet using maybe A to Z or something, or using some kind of numbers. This is similar to what we will do now. To do this, we go with a normal style of querying table, and then we will select the columns we would like to see. So so maybe here we want to select the unique key, which is basically like the identifier of the different cases. So we want to see the unique key. We select the unique key, right? And then we also select maybe the complaint description, right? So just the complaint description, right? And then we select the date, right? So when we want to select, so maybe we want to select the created date because we would like to sort the unique key or the complaint, based on the date that the request was created. So now what we have is we're selecting the unique key complaint description created date, we're selecting it from this data set, right? And then we decide to basically now apply our order by, because if we were to run this data set, what we will get as a result will be just another round of data set, but without any kind of order to it. But if we wanted to order this data set by this created date, so we can write an extra function which is basically order by. So, and then we will call the name of this data set, right? So we're going to order it by the created data set. Now, we could decide if we run this data like this, we notice that it will go from lower to higher. So basically the earliest date, which is 2014, and then it will gradually increase. So you would notice like it's the 2nd of January 2014, but by the time you go even lower, you will even get to a point where the whole data set on the last page is basically 2021 July. So basically you see that the data set is increasing as it is going. So now if you would like to have the data set the other way around, you would have to include, beside the created date, you would have to include something called DESC. Now, this ESC is basically a descending trend. Now, the exact opposite of DESE, which is descending, is ascending. So you could also put the ascending, and then you get the same answer that you get when you do not put anything there. So this is like the code for ascending, but I mean, you will get the same thing as not putting any direction. So it's the same, but then when you put the descending, you will get a data set that ranks the highest, the most recent case, and then basically falls from that to the oldest case. So here you have like July 2nd, and when you go down, maybe you see like this is starting at 9:29, but when you get to down the table, it's getting to 7:20, which is like some 2 hours before. Now, if you keep going, so the next page, you see like we have like the 1st of July. And then when you go to the next page, you have, you still have 1st of July here, but the time is decreasing. And then you get like this 30th of June. So this is like the trend. It's just basically like trying to order the data set by a certain field. Now you could also order by 2 fields. So for instance, you would like to order this data set by maybe, for instance, you would like to order it by 2 fields. You could decide that maybe you want to order the data set by the complaint description and maybe the owning department, for instance. Now, so maybe here we decide that we have the complaint field, right? So we include we include the owning department, right? And then we remove this created date just for an in casity. Now, basically, when we come here and we say we want to run this query, we notice that if you are running without the order by, you get the same thing, right? So you get like a data set that is just basically like random. But now you want to order by the column called the order by. So you decide to order by complaint description and then owning department. Now, if you decide to go this route, you notice that you have basically called this ascending and ascending. So when you run this query, what happens is that the whole data set first arranges based on the first part, and then when there is a tie, it basically arranges with the second part. So when you notice that there's so many there's description that is the same and all belonging to the same department. So the first set of data is, like tying based on these two, the same columns. So we could basically put something that makes the case slightly different. So then it basically changes the dimension. So maybe we could add something like an address, right? So the incident address. So when we run this query, what basically we will see is that we will see that yes, it will be ordered by these two fields, basically with the most the ones that is closest to A starting in first and then basically like going alphabetically down. Now, if you notice this, there is a lot of tie here, and because of that, like the data set has been so, and maybe when you get to the last page, you will notice that you have like the wildlife exposure, and this is like a second column. Now, this is following a certain type of pattern, right? Because for every complaint description, maybe it's going to the same, for the same type of complaint description, it will go to the same department because the same department owns this type of description. So this is like a kind of duplication of like, the column. So maybe we'll just remove the owning department from the data set and then we just keep only complaint description. Now, maybe now we do not, because we notice like the complaint description is basically like the same because it has a lot of similar types of complaint decision, but we want to still rank this based on maybe the unique key. So we want the unique keys that is like, we want to have a chronological arrangement of the unique key in cases when there is a tie. So when it's a tie, so in this case, wherever you find like the same thing, then all these cases are in a tie. But what would be the deal breaker? So here we'll first sort by this complaint description, and then we will sort by the unique key. So when we run this query, what happens is we will notice immediately that so we have a tie because everyone is like, related to the complaint description. But then the unique key will now be sorted, because there wouldn't be a tie because it's unique to the individual cases. Now it will be sorted, in a chronological order from a number perspective. So you see like the 15 is gradually going from 15 to 16, and then it is going to 17, and then it's going to 18, basically like that down the line. So this basically creates some kind of chronological order that basically can be used to distinguish the data set. So also, if you wanted to maybe say like if for one row you would like to use ascending, but then the other row you would like to use descending. So basically, for a column you use the ascending, and then for the other column you use the descending. So maybe we could use ascending for the first row, for the first column. So in this case we didn't even put the ascending because on the default the cases are on ascending, but we can put it anyways and then say descending now. So what happens when we run the query? Now, when we run this query, what happens is the column, so basically it sorts this column first. And then when there is a tie, then it basically now arranges this column from a descending perspective. So from the highest to the lowest. So it's basically reducing in terms of the number down the trend. And you go from 21 to 20. And then maybe you go to 19 and then you go to 17 and all these kind of numbers. So this is like a way to sort. So basically you sort based on the fact that, like if you want to first sort a column, you put it first and then you put the second column that you would like to sort on. So what happens in this case is when we get to, like another letter, like, wild exposure, if we go to wild exposure, we notice that by the time we get there, so wild exposure, I'm just trying to look for where wild exposure actually starts. So when wild exposure starts, so we will get there soon. This is a very huge data set, that's why. Anyways, so So basically, like we just noticed one major thing we noticed with the wild exposure, it's also like having the highest number and then it's basically reducing down the line, right? So if we go to the first page, we see like it first takes the lowest in terms of the alphabetical order, and then it takes the highest and basically goes down. Now, when these ties are solved, and then it will go to the next one on this line. So maybe you get to a B of maybe some other, letter that is following afterwards. So I think this is already a long video, but I hope you get the drift. If you don't, you can put your questions in the comment section, and then we could have a quick chat over it. We'll be looking at something else, right? So what other part we'll be looking at here is basically the group by. Now, what is the group by? The group by is just very much like, the same way you basically aggregate data. So from here now, maybe you want to aggregate data. A lot of us is used to using the pivot table, right? So we used to pivot table to summarize our data set, right? The same way we use the group by to summarize the data set. So I'm assuming we would like to see maybe the city, and we want to see like what is the different quantity of like what is the different what is the total sales that was made in different region, for instance. Now, what we usually do in Excel is just come here and say that we basically come and create maybe a new sheet, and we just come and say, oh, we want to see like the region, for instance, and then we just put the region, right? Sorry, we basically put the region here. So put the region, right? And put it in the rows. Yes, exactly. And then we just decide to say, oh, what is the total sales? And we put it in the values and we come with a sum. Now, this is exactly what we do also in using the group by. So basically, we group by the region, and then we just do the sum of the sales. The same way we could come and count the number of sales. Also, like, we could basically count the number of sales, in different regions. So the same way we do all these things in SQL is the same way we do it in, the same way we do it in Excel is the same way we do it in SQL. This part of the course is just to make you see that, there's nothing really special about SQL. Everything you could maybe do in Excel is the same thing that we're doing in SQL. It's just maybe a bit faster and, a bit much more structured query, and just making things like a lot more efficient. So that's all. Now, in this section of the class, we'll be basically looking at how to aggregate data. So what do I mean by aggregate data? So for instance, now, in a typical office setting, like we get data at the very granular level. So basically we're getting data of, sales data at maybe like, instant level, at maybe like order level. So for every order that was made, you have the transaction detail. Now, in the real sense, most people are not really, I could almost say like 95%, roughly 95% or even more of the cases, nobody is interested in like, this granular data, because, the business just wants to see like, maybe for instance, they just want to see like how many, like how many goods were sold like the previous day, or maybe like, how much money was, sales was generated, or maybe, like what was the total profit. So when you look at, this type of data, is basically like an aggregated data. So it's like an aggregated data of a certain period. So it's either you're taking like a sum, or you're taking an average, or you maybe like you're taking a mean, or you're taking a median, or something like this. So now the same way, as an analyst, it's very, very easy for the analyst to basically calculate this type of, do this type of analysis straight away from the, from SQL. So in this class, basically, we will look even more into, how we could use like this type of, granular data and make some kind of aggregated, sense out of it. So for one, we have this sales table. So in this sales table, when we look at this sales table, it's just basically like liquor sales table. And then the sales table is almost like 6 gig or worth of data set. I mean, I will just close this once because then they're basically not useful for analysis now. This is the preview of the sales data set. So for the sales data set, you have like the invoice and item number, you have the date, you have the store number, and then you have the store name. And then you have like the address, the city of, I guess, the store, and the zip code of the store location. And then you have the county number, the county, like you have the category name, and then you have the different item description, and then you have the cost. So that you have the pack, you have the bottle. So basically, this seems like basically like an inventory of a couple of stores, right? And so basically, we can just basically take it as the inventory. And so basically, for this case now, they have like this triple sec thing basically costing at 2.33, and it's costing 3.5 on retail. And so they say like how many bottles was sold, and then they was able to get like 4 times 3.5, which is basically giving us 14. And then you have like the volume sold in liters, which basically also is I think it's basically like a multiplication of this number of bottles sold times the bottle volume in milliliters. And then so basically have like that. So we have this data set like this, and so basically we know what we're looking at. So for instance, now they say like different stores are selling different things, right? And then maybe we want to see like, for instance, we would like to see what store is basically what is the total amount that each store is getting. So you could see like for each store, maybe you might see a certain store a couple of times. For instance, you have this store, it's showing like a couple of times here. So basically it has like different goods, and it's showing like, it's basically telling you different items that is in different stores and how much they have sold at the time being. Now, when we look at this, we can see like, okay, so maybe we want to do this analysis of, how much is different stores selling, right? The total amount that different store is selling. So to do this in SQL, one of the easy ways to do this is just to say, okay, you want to have the store name. So you want to select the store name. First thing, when you want, whatever you want to get as your answer, it goes into your select, right? So like the first thing you select is maybe your store name. And then you want to see how much has each store sold, right? In total. And then you go and you see that, okay, so we would like to see how much each store has sold, and we just go to the sales dollars. But then now we do not want to see it individually. We want to see the total that has been sold by each store. And then we just put a sum, we put a bracket, and then we put the name of the column that we want to see, because we want to see like a total. And then when we come here, we can see that we're doing like something like a sum of sale. Now, to do a sum of sales is not like sufficient, basically, because like we could, if we try to run this query, it's not sufficient to go. We still have to do one other thing when we aggregate, and this is including what we call the group by. So now this is just basically, the group by is just basically like, what granularity would you like to see the final result? So you would like to see the total sum for different stores, right? So which basically means like you like to see it at the store level granularity. So basically you will group by the store name because of that. So because you want to see the data at the store name level, so you group by the store name. And then when you run this query, you will notice now that your answer will come out as the different store names and the total amount that they have sold, right? This is the total amount that each store has sold. So this is how you basically like, get to, your analysis. So basically we can see like we have a lot of stores in this case, right? So, and we have like almost 2,000 stores. Another very good way to, categorize this, maybe we want to see how different counties is doing. So maybe we assume like we have lesser counties than stores. So when we put the counties in this case, we could basically like change. So we want to see how much is sold in different counties. And then when we group by county, when we run this query now, we see like it changes from the store name to the county. So how many counties we have? We have like 200 counties. So basically for each county, you can see what they have sold, right? And so this is that basically like how it is. And also, I mean, we could also take a city level, right? So city level and say, oh, we would like to check for each city. So how much is being sold in each city? So how much was sold in each city? So we can say, we put this, we select the city, we select the sum of sales, and then we, group by the city, right? So when we run the query, also here we get even we have like 843 because then we have like, a couple of cities, and then this is the amount that each of them has sold. Now, I mean, we noticed also like this is bringing out a very strange figures. It's because we didn't name this column, so we could easily name this column by putting an as, or maybe basically we can also put a space and then say sum, total sum in, maybe we could call it total sum. In dollars. Now, when we name the column like we did in the first class, we noticed that we cannot just put some spaces in between because this will be very confusing. And so we basically put like maybe an underscore. If we, however, want to put a space, we could just basically like, put this into some kind of double quotation. And then this is already possible. To put it in a space is already possible. So here we have so when we run this query now, oh sorry, this is because we didn't put an as here. So basically, yeah, I think just in this case, I think it's really better to just put an underscore, I guess. So this is not working in the case of BigQuery. And then I think like with an underscore, we have everything that we need, right? Okay, we still have this here. So basically, we just have our queries, giving us our answers back, right? So this is like different ways of basically like, summing the data set. I mean, we can also do some other analysis, like maybe we could find the average, right? So basically, we could find the average sales in maybe the average price of like each category, for instance. So basically we have different category names. We notice like in the shops they sell different types of things, and we want to know like, so for triple sec, for instance, what is the average price of goods that are being sold under this category. So basically here what we do here is we just basically come and take the category name, because then we want to know based on the category name. So in this case now, we group by the category name and not by, and also in this case, we're not trying to find the sales in dollars, but we want to see like for specific items. So what is the cost of specific items? So maybe we can use the retail cost, for instance. So what is the average cost of each category, basically like that. And then when we run this query, now we could see like we have different categories. Now there, certain rows that is null. We could basically like exclude these rows by using some kind of approaches. And in the previous classes we also learned how to use the where statement. So for in this case now, we could basically come here and say we put a where clause, and basically say like where category is not null, for instance. So in this case now, it filters every case where category is null, it takes it out of the equation, and then you have like a much more clean data, I will say. Not a very clean, but much more clean data in this case. Welcome to this class. Now in this class, we will be looking at how to even aggregate data in a different way. Now, we have this data set called the sample files. Now, this sample files data set is located in the GitHub repository folder of the BigQuery public data set. Now, To use this BigQuery public data set, what happens is, we basically see this sample files, right? And it has like a repo name, it has reference, it has a path, and maybe some other details, right? So when we preview the data, we notice like this, right? And then we also notice this is like 72 million rows, or maybe 73. So when we try to query this data, like if we wanted to count the number of rows that we have in this data, right? Normally, if we were to write a select star, for instance, this means that it brings the whole data set back. Especially if we do not limit the table, right? Now, normally, if you want to count the number of rows of this data set, then you could basically come here and do like a count, and then you put a star in between, and then you can just run a count. So when you run the count, you will see that this basically tells us the same thing as this right here, which is also referring to the number of rows. However, if you wanted to be more specific, maybe you wanted to know for each repo name, how many rows is available for each repo name. So here now, we will do something similar to what we did in the previous class. So we are trying to count by the repo name, right? So we will put the repo name, and then we will group by the repo name. The repo name. And then when we run this query, we will get, for each repo name, we will see how many times it is observant. It is, in the data set. To even better still, make our answer even look even better, we could decide to order the data by the number, the times, that it occurs. So we will order by count star, for instance. So if we do this now, we will notice that the data is coming from the least to the highest. And then we could also see we wanted to see it from a descending perspective. So bring the most frequent repo in the data set on top, and then basically just go down like that. So here we have like the top 6 repos, right? So here it has like the highest, and then it basically just goes down from there, right? And this is like how to basically group by. Now, when we group by, we could also use numbers to do the group by. So here we have like the position 1 and then the position 2. So if we want to group by, we could basically group by 1. This basically tells us that we are grouping by the repo name. And then also we could order by 2, because this is the position of that. And then when we run this query now, we get exactly what we did in the previous case, because this 1 and 2 just basically represents the repo name and the count respectively. Now, another thing that I would like you to also note is, so for instance, you have this repo name, and each repo name also can have like multiple references. So because you could be in the master branch, or you could be in a different branch, right? So, and then this is like having different references. Now, if we wanted to also know, maybe we would like to go to the granularity of seeing, okay, for each repo name, right? What is the reference? What is the number of times for each reference is showing in the repo names, for instance? Now, we could basically include this reference and put it here and then do a count. However, if we were to run this query like this, it wouldn't tell us anything that is useful, because it basically is expecting us to do the count by, because we want to group by the repo name and the reference. So we want to count for each repo name, we want to count for each reference in each repo name, right? How many times does it occur in a data set? So now we have to group by these two columns, and this now means that we have to group by 1 and 2 based on the positioning. Everything is based on the positioning. If we were to take this reference and put it as the last case, then we would have to group by 1 and 3. Now, also, if we basically order this data set now, if we run this query like this, we will notice that this does not affect the count in terms of the order by, because this 2 is pointing to the reference, and then what you will notice is that the reference will be arranged in a descending order, and that's why you see that the reference is starting from Z sum, and then it's basically going down to a Y, right? So basically what we want to really achieve here is we want to order by the count, and then we can basically do our descending. And then here what we see is, we notice that basically for this repo name in this reference, it shows this number of times. And basically this gives us an idea of, what repo name and reference is like the highest in the data set. And basically we just go downhill from there. Now, in the next class, we could basically go, into discussing, some other types of count. In this class, we would like to take a different approach to see what if we wanted to count, like unique cases. If we want to count unique cases, so we have our data set again, right? And when we want to count unique cases, we will see how these cases could be done, like in a different way. So, you have the select, and maybe now we want to see, okay, we have like 72 million rows in this data set. But then really we want to know how many unique repo names do we have in this data set. So what we can do here is we could do a count, and then we could do distinct. So we put like a distinct, in the first part of this class, around when we discussed the select, we had this distinct basically, which tells us like, which brings the unique fields, right? In this case also, we would use a distinct to maybe like limit the number of times that the repo name is repeating. So basically it comes back only once, and then we count it only once. So when we run this query, for instance, what we get as our result is the number of distinct repo names that we have, which basically brings back 173,000 distinct repo names. So if we want to basically like also we want to also count, maybe for instance, we would like to count the number of references that is available for each repo name. So here, what are we trying to do? For each repo name, we want to know the number of distinct references. So now what we are doing is we're trying to count for each repo. What is the number of references? So here, this is where the definition is very important. So for each repo, that means we want to group by the repo name. And then we will count the distinct references, right? And then we can group by 1, like we discussed in the previous class. Now 1 basically represents the repo name. Because we are grouping by the repo name, we could also decide to just write the repo name here instead of using 1, right? And so when we do this, when we run the query, automatically we can see that for this repo name, it only has one reference basically. So if we want to see the repo's names with the highest number of references, we could basically order by 2, which is basically this part of the query, or we could even bring it here and copy this, and then order by the count, and then put a descending. So this allows us to see the top, maybe the top 6 or the top 9. So here we notice, like, for each repo name, it seems like they only have 1 references, which is basically surprising, right? So this is the idea of counting distinct, right? So this is the idea. In the next class, we will try to combine everything we have learned. So in terms of the aggregation, in this class, we will do another type of aggregation. So we already did like sum and average, but now we would like to do mean and basically like minimum and maximum. This is the idea. Now, in the minimum and the maximum, what we are trying to do here is we are trying to see how we can, select the minimum, or we could get the maximum from a certain data set. So first, when we try to query the table, now, before we query the table, we could even preview the data. Now, we see that we have an airport traffic data, right? This airport traffic data is found in the COVID-19 geotab mobile file, mobile impact in EU, basically. Now, maybe for instance, we want to see, we would like to see for different airports. I mean, we have different airports in this table. So we have different airports in this table, and maybe these airports are, appearing like multiple times. Maybe they could have like one airport applying like, coming out like, multiple times. So maybe because, for instance, if we apply one thing we learned in the other class, maybe we could say select star from this data set, and we basically come here and we put a where clause, and we say we want to see this airport name, for instance. So how many times does this airport name occur in this data set, for instance? So maybe Kingsmead Airport, right? So when we run this query, what we see is the Kingsmead Airport is occurring in this data set 464 times. So maybe we are not interested in, like seeing the data set. I mean, maybe seeing this, maybe we're not really interested on seeing like this granular level of data, but maybe for each airport name, we want to see what was the first time they appeared in the data set, and what is the last time they appeared in the data set. So in this case now, when we write this query, we could say that since we're trying to count for each airport name, so we will say airport name, and then we will say, so we want to see the earliest date that the airport featured in the data set. So we put the date. So we're trying to find the minimum date. So this is like the earliest date, right? So the earliest date. And then we are trying to find the latest date, which is like the, most recent date. So this is like the latest date, right? And then we name it the latest date. And then just like in the fashion of aggregation, we will group by. So we're trying to find this data for different airport names. So we will just group by the airport name. And when we group by the airport name, what we can see here is we will see that when we run this query, for instance, now we will get different airport names, and to see the first time this airport was featuring in this data set, and then the last time this airport was featuring in this data set, right? And this is basically the idea of, minimum and maximum. If we want to have an idea of how many times this airport basically have featured in this data set in between these days then we could just put a count star, which basically counts all the, data set. Counts the number of times that this airport name is in the data set. So you have the count of occurrences, right? And so when we run this data set, what do we get? So basically we see that, we have this Newark Liberty, which is occurring for 71 times. And, basically like the earliest time we saw it in this data set was 16th of March. And then the latest time was 30th of June. So this is the idea of, doing this minimum and maximum date. We could also do it on numbers, for instance. So basically we could do it on numbers also. We can apply this to numbers as well to see what is the minimum, percentage of baseline that we have for each, for each airport. So maybe we could even add this to our data set, for instance. So we will say mean of baseline, percentage of baseline, right? And so basically here we could even name it minimum percentage baseline. So when we run this query now, what do we see? When we run this query now, we will see that for Calgary dataset, airport, it shows basically like the earliest date was, 16th of March to 2020, and the last date was 30th of June 2021. And the number of occurrences is 471 in the data set, and then the minimum percentage of baseline in the whole data set at any day was 9%, and it was 100% at another day. Now we haven't said basically we're just saying like the minimum percent of baseline for this period when this airport name was paid in this data set. We do not attribute this minimum percent to a certain day. Now in future, when we go into even much more intermediate level of this course, we might even be able to do some really complex, more advanced analysis using some of these features, or maybe even doing it in a different way. So basically this is what, this is just basically minimum and maximum. And this is the way it works. In this section of the class, we look at all the different types of join. So for instance, we look at the inner join, we look at the outer join, look at the left join, and then we look at the right join. So basically these joins are basically very, especially the left and the right join, they're kind of the same, but I will explain what makes it different. So first you have the inner join. Now in the inner join, you have something like this. Basically you have two different tables, and then we're selecting the data set that is common for both cases, right? So basically we only look at cases that is, common for both sides, and then we bring out all the columns for these two cases. So for example, now you have this type of data set. So for instance, you see in the US data, you have the first, you have all these guys here, right? So, and then you have the same case in Europe, you have the Europe data set. Now, if you decide to join this data set on, say the name, for instance, now, so basically you try to look for the cases where the names are, similar. So basically you join on the name. So maybe Steve is the same as the Steve here, right? So what happens is that when you join on Steve, what you get is you have only, so basically when you say it's an inner join, you get only the cases that is common for both tables, right? So you have Steve is common, and then you have Tim, which is common, and then you have Paul, which is common. Now in this particular example, you do not get any other case, and then this becomes your new table. I'll also look at this example, which is another very good case, right? So in this case now, we're joining on the country ID. So when we join on the country ID, we join these two tables on the country ID and then the ID here. So what happens is that we only get the row here that has the same row here. So basically we have 3 and 3 here. So it basically selects this data set and includes this guy here. So basically you have the new data set, and then it's basically dropping out the rows that is deemed that to be useless. So basically it's not including these rows in the data set, right? So this is like an example of what an inner join is. Now we could basically look at what is a full join, right? Which is basically a full outer join. Now a full outer join is like a data set that combines everything. Now what happens with a full outer join, for instance? Now the full outer join is basically like looking at the columns that is available in one and looking at the columns that is available in the other. Now there might be cases where it's basically like having the same similar data that is like basically joining, and then there might be some that is not joining. It will basically bring the whole two tables, but it will join the ones that it can join and put nulls in the cases where it cannot join. Now I will give you a much more specific example by saying the full outer join, right? Now the full outer join is also called the full join in some cases. So you could call it the full join and you can call it the full outer join. Now in this case here, what do we do here? So basically they're trying to join this table. Now they say like they're trying to join the table on the user ID, for instance. Now this user ID, they're trying to look for this user ID in this case. So what happens is this row basically matches this row in terms of the key. And when it matches this row, it brings it out as the first row. And then this row is basically not being able to match anything because it's basically null and it doesn't have a null case in the second table. So basically it just comes out null. It brings everything from this row, and basically since it doesn't match anything, it just brings null in the other side. Now this is a third case. Basically you have like user ID, which has like this key 2. Now this 2 does not exist in this user ID as well. So because it doesn't exist, it basically brings out this part of the data set at the side where it belongs and basically has null for the other side. So this is how the full outer join works. It basically selects every part of the data set that it can select and just puts the null in the remaining parts, right? So it's basically matching the case that it can match within the two data set. And for every case that it can't match, it brings out the data set anyways and basically puts a null at the parts that it cannot match in the other side of the data set. So this is like the full outer join. Now, this is a case of full outer join, and then next we basically look at another case, which is basically the left join or the right join. Now the left join and the right join is basically the same thing, because it's very, very funny, but then to say like it's the same thing, but it's basically the same thing. So what is happening here is just basically you have like two tables that is trying to match, but then you decide that you do not want to, you want to select everything in one table and just want to select like the matching cases of, and then you're not selecting everything from another table. Now, this left join and the right join is basically determined by the arrangement of the table. So the first table is going to determine what you call it. So first you maybe say like you want to select everything from the table, like the left side, then it becomes a left join. Now, if you decide to select everything from the right side, then it becomes a right join. And I could just basically show you some examples, so then you have a better idea of how this looks like in terms of a data set, for instance. Now, if we look at the left join, now the left join is also known as the left outer join in some cases, so it's totally fine if you see it somewhere and they call it a left outer join. It's totally fine. So here you see basically that what happens here is you try to join these two data sets, right? And then when they're joining it, they're basically joining it on the F points. So this is the F and F, right? So here you're basically looking for 1 and 1, right? Now, if this is a left join, this is the left table, this is the right table. So you're gonna get this full data set, but you might not get this data back. So what happens here is you try to look at this, and where does it match? It basically matches here, and it matches, this 3 basically matches here, right? So basically you have like A1, 1, and then you have B1, 1, which is basically this row, the first row, sorry. And then when you look at the last row also, you see like it's basically matching. So it matches this part of the data because 3 is also 3 here. And then it's basically bringing out this right source, right? So now in the last case, this A2 does not match anything here because this 2 is not existent in the F section of this part. And so what happens is it's because it's a left join, it brings this A2 for this table back and this 2 for this table, and then brings a null, which basically signifies that it cannot find it in this table, but then because we want the left join, it's going to bring the data set for us anyways. Now, this is the left join, right? So it's just basically the same thing as the right join, but it's just when you basically say, oh, this is the left and this is the right. So if we were to take this table and bring it here, and take this table and bring it here and call it the right join, we'll get exactly the same answer. Anyways, I will still show you what a right join is. So then it makes more sense, right? So what is a right join? Now, a right join is basically, so let me see. Now you have, I'm trying to look for, a perfect example for a right join. Yes. Is this? No, this is not. Yes. So here, what do you see here now? Also, do you see this same case of what we are saying? So here you see like 2 different tables, and they decide to join the tables on the I. This ID is basically used to join this part of the table, right? So when you look at it, the right join on this ID, parameter types ID, which is basically this table, and then they try to join it on this table, this other part, but then they're using this parameter ID to join it. Now you see the cases of this ID. For every case that this ID finds its own ID here, it brings it back, right? So basically you have the first one is matching these 2 rows. And so what does it do? It brings these 2 rows twice, right? And then you have these 2 rows. However, this 2 does not match anything here. So basically it's like not going to bring out anything because also the reason why it doesn't bring out anything is because this is a right join and this is a left, this is the left table, this is the right table. So it skips this completely. And then you have the 4. 4 is basically, it finds 4 here and basically brings out this row. So what you notice here is it's exactly like this that you find here, right? So this basically makes sense. Now in the last row of the right, this table, you can actually match it to this table, and then you have something like this, and then basically you have this straight like that. Now, because this row has not been matched to anything, and this cannot be matched to anything from the left table, but this is a right join, so it has to bring everything from this table. And so what happens next is this table comes to this part, and because it doesn't match anything, you have a null. So basically this is the right join, and the right join is basically like the left join, as we already have said. It's just the difference is just the fact that what you call the right join, or what you call the right table, or what you call the left table, because then it's just a case of your arrangement. Now in the class we will basically demonstrate how the join looks like, so then it makes more sense to you. In this class we will look at how to join tables. In the last class we were trying to see, to just have a general overview about joining tables, but in this class we'll actually put it into practice. So now if you go to this, there is this folder called the GitHub repos, right? And when you look at this folder, you see a couple of data sets that is in the folder. Now you see the sample repos, you see the sample files, and basically you have like the schema. So the schema allows you to have a view of what the field names that are available in this data set. So for instance, you have the sample repo, it has like the repo name and then the watch count. Now, when you look at this sample files, you notice that it also has the repo name, it has the ref path and mode and all this kind of thing. So basically, it's also very important to see if you can get any kind of information about the data set that allows you to basically understand the data set before you actually do some kind of join. If you do not have enough information, you can also do your own analysis just before you join, because it's very important. Now, first you see, the description, it said it's a sample file metadata for files at head from the top 400 repository in the sample repo. Okay, good, nice one. Now, we will still go ahead and maybe just continue, reviewing the folder. So also we have the sample content. Now, the sample content is also like having some schema, and it's basically arranged in a certain type of way. Now, one thing I think I have, gotten a bit from this, this table so far, it seems like, so most of the files are actually coming from the sample files, right? So basically, like, this looks like the most granular data. Now, I know that this might not make sense to you at this level, but I will basically explain myself in the future classes, maybe in the much more intermediate classes. So first, now you could see all these tables are having like different, they're having like different stuffs here, right? So let's just see. Now, when you look at the preview of this table, for instance, so you have a table with license, and the schema has the repo name and it has the license, right? So there's one very important thing you want to see. So we want to join this license table to maybe say this sample repo. Why? Because we see that there is a common field. So it seems like this idea of this table is to have the watch count per repo name. So when you see it, maybe the preview, it has like different repo names, and then you're trying to see, okay, so what is the watch count for each repo name, for instance. Now, this kind of makes sense. Also, when you come to the licenses, you maybe see that, okay, so this is also showing like what is the the license for different say like repo names, right? So you're seeing like the license for different repo names. Now, before you join these two tables, like basically what we are trying to do is we're trying to extend the table. So first, we want a new table that has the repo name, the license, and then the watch count. So we will join the repo name. We're going to join the two tables, the license table and then the sample repo on the repo name. And then this will basically allow us to have like a full data set that has like this repo name. Now, first things first, you want to do for your analysis, right, is you want to see, because then you want to know, you want to have an idea of how to join the table. You do not want to join the table and cause some kind of problems by maybe like joining incorrectly. So one thing we could first do is do a little bit of analysis on the table, and then this will inform the kind of join that we will use. So first we query the first table, which is the sample repo. Now, what are we trying to figure out here now? For instance, because we're joining on the repo name, we want to see if, if for any reason it's likely that we have the same number of, repo and with the other table. So, like when we come to the license table, for instance, we see that this license table seems to have like 3 million rows. So it's either maybe you have like double, maybe you have like double, you have like some kind of duplicate of repo names. Maybe a repo name could have like multiple licenses, for instance. And, and maybe this is the reason why you have like this number, because when you compare the number of rows here, and when you see the number of rows here, it seems like it's kind of different. So here it's like you're having like 400,000, but here now you have like 3 million rows. So basically, you want to know exactly what is the difference, what constitutes between this difference. It gives you an idea of what you're looking at, and so that you would know how to join this table. For every kind of use case that you want to use, then you have an idea of how to join the table. So now, one thing we could do as an analysis is to just count the distinct repo name, right? So we count the distinct repo name, which basically tells us what is the number of distinct repo underscore name. So when we run this query now, we see that we have exactly 400,000 sample repos, and basically this confirms that there is no duplicate repo in this table. So there is no duplicate repo, so you have just one repo and then the watch count. So on this part, we kind of understand that. So now we have to do the same analysis for this table. So when we query this table, now we have an idea of, we're saying like, okay, what is the distinct repo name, for instance, now. So we see that the distinct repo name, for instance, is also like 3 million rows. So this basically tells us a very, very interesting thing. What is this thing telling us? It tells us that this license table has more repo names than this sample repos table. So basically, if we were to join the two tables, then we have to be sure on what exactly we're trying to achieve before we join the tables, right? So another thing this tells us, it tells us that the license, because the license table has more rows, maybe what it means is that maybe not all repo names have a watch count. So this means that for the ones that don't have a watch count, maybe they're not featured on this table, for instance. I mean, it's just an assumption. This is how we build analysis. We build analysis from, curiosity and, assumptions. And then we just basically go ahead and check them, right? So we will now go ahead and see how, we could basically join this table. So first things first, we want to understand, what are we trying to achieve when we want to join this table? So for instance, if we want to, now, we have been able to build the idea that the license table has much more rows than the sample table. So, an assumption that we have also maybe threw up in the air is that maybe not all repo names has a watch count, and maybe this is the reason why we have this discrepancy. So we will basically try our hands on different types of joins for different use cases, of course. We're going to look at how to join two or more data sets. Not exactly looking at it from the Excel perspective, but maybe like we're just trying to demonstrate with Excel what a join looks like, in SQL. Now, the different joins in SQL, right? So you have the inner join, you have the left join, you have the right join, you have the outer join. Now, the inner join is basically trying to like match fields that match each other and basically discard the rest of the data. So basically we assume in some cases that maybe, like for every case that we have in one data set, it exists in another data set. Or maybe, of course, maybe we just want to get only a certain part of the data set, for instance. We only want to get a certain part of the data set that is matching our other data set. So I will show you an example of what I'm saying here now. So if we were to, try to do a VLOOKUP, this is very much similar to what we do in joins, right? So maybe we have these two data sets. We have the orders data set and we have the people data set, right? Now in this orders data set, we have a certain row, a certain column, which basically is the region. And we have every other column basically talking about the, the customer, the segment and all these kind of things, and quantity sold and all these very, very important fields. Now, in this people data set, we basically have like the manager of the different regions, which is not included in the orders data set. So assuming we want to bring this people, data set into this, maybe we want to bring this extra field into this part of the data set, then we can join the two data set. So basically we will do something like a VLOOKUP. Now, when we do a VLOOKUP in Excel, basically we say like VLOOKUP, and we put the VLOOKUP and we basically come here and we're searching for like, the certain row, right? And then we basically come here and we go to the range and we say, oh, and then we're just basically like joining on this, and then we're returning something like, the second column, right? And then we put maybe because it's sorted already. And so when we have this, I kind of made a mistake, so maybe I will just take a little backtrack. So basically here we're supposed to lock the rows, so then we can consistently have our if you do not already understand Excel, you don't have to worry, because this class is not an Excel class. You just have to try to understand the SQL. So when we basically go ahead and join all these cases, we can see now that the manager row is basically tallying with what we have in this part. So basically for the central, you have Kelly Williams. Basically, you also have Kelly Williams for the central. And then when you go to the west, you have Anna Andrea. And then basically you have the same for Anna Andrea in the west. So what are we trying to say here? What are we trying to say here is basically we're saying that like by joining this two data sets, we have more fields. So basically it helps us to identify a field. Now, this is a classic example of an outer join, because then we do not really care if, we don't really care if maybe there is a certain region, an extra region that is here and it's not there, right? But if we are very, very specific that maybe we could come to a situation where we will not have this central, for instance, if we were to remove this case now, and then we notice like this is saying not available. Now this is, this is a case, right? So because then now we say like we see some cases that it's not available, right? Do we decide to keep the data for those cases, or do we decide not to keep the data? Now, if we decide to keep the data, this could be an example of a left join, right? So basically this is the right table, and then you have the left table, and it basically like doesn't have some rules. So we decide to keep the data in this case, even though it's not available. Now, if we want to convert this to an inner join, what an inner join would have done is basically it would have filtered out the cases that do not exist. So it's just basically come here and it will say, oh, I'm only going to select the cases that is existent in the two data sets. So for an inner join, it's going to just come and say, okay, so I don't want to see any case that is not available, that is going to give me not available. So here it's only select the case that is available. So you cannot see a central case, for instance, here. You can only see the south, east, and then the west that is available. This is what an inner join is doing. Now, like I said, if we were going to leave the not available columns, that would be very much like a left join or a right join. Now, a left join or a right join is just basically left or right based on the arrangement of the table. So for instance, if you want a certain part of the table, this is like basically the certain part of the table that is showing all the data set. Then this is the left join. This is the one that we used to call the name of the data set. So if this is a right join and we do not want to show like, we want to show this type of part where the manager is not available, then basically we could still call this a right join and say this is the right side of the data, so which is like the orders table. Now, this is just a little bit of, introduction, just trying to like make you have an idea of what joins are doing. And so basically prepares your mind. It makes you understand, especially if you have an Excel background, it prepares your mind for what SQL is. Like we'll say, SQL is not really anything that is super special. It's just basically like, looking for a much more efficient way of doing the same thing that maybe Excel is doing, because also like maybe when we get more advanced, then we can see like even how much more efficient SQL can be than, using an Excel or Google Sheets to, do manipulations on data. In this class, we will take a much more, direct approach to basically see the first type of join, which is the inner join, right? So what we established in the previous class was we knew that the license table had more repo names, right, than the sample repos table. So maybe if we were to ask ourselves this question, that so we want to see for every repo name that, that basically has a watch count. For every repo name that is like, common in the two tables, right? We would like to have the license, and then we would also like to have the watch count. So now this is a very interesting case. So what we do in this type of case is we know that the repo name is common to the two tables, right? So we say select star. We just want to select everything. So now we will put from the first table, and then we will join, or we will say an inner join. But just know as well that a join is the same thing as an inner join. So if you do not specify what type of join you're using, then it's a default that join is equal to an inner join. So then we will bring the second table. So here we have the licenses, right? So the next table we want to quote here is basically the sample repos table. So we want to join the samples repo tables. And we're going to join it on. So basically, what another very important thing to do when you're joining tables is to put an alias to the table. So, in the previous class, we kind of looked at how to put an alias to select. In the same fashion, you could put an alias to the tables you're joining. So you put as, so you put the alias, you name the table. So maybe you name the table LIC in this case, and then you name this other table, say like SAM, right? So now when you want to join, you have to join on the common field, right, for the two tables. So you have the LIC dot repo name. So you are joining on, and then we take this same part, put it here, but in this case now we change it to SAM. But please note one thing. So now we are currently joining the repo name. It's common in this case that the same common field is named the same thing, but it doesn't always happen like that. So when we run this table, we will get our results. So what do we have? Now we have a new data set, right? So we have a new data set that has like the repo name, and it basically has like the two. So first you see like the repo name of the license, and then you have the license, and then you have the repo name that is coming from the sample repos, which is basically like named with, with an extra one, something like this. And like it's kind of similar, right? It's the same. And then you have the watch count, right? So this basically has selected the rows. That is the cases where the repo name is the same to like the repo name in the two tables. Now, if you notice, we have a second table, the second column. This repo name column is like appearing twice. If we want to be more specific with selecting, the fields that we want to see, then maybe we could also, use the select function, properly here. So we could say, for instance, that we want to see the repo name, right? However, if we were to just write this repo name like this and we run the query, it will give us an error. Why? Because you see, in the two cases, you have this repo name. So what we do is we decide to select one of the cases that we want, and then we just put like LIC. I'm assuming we want to pick the one from the LIC, and then we will go ahead and basically select the other columns, which is basically watch count. And the watch count is coming from sample, so it's not as important to put the alias here as much as it is the case of the repo name. Why? Because the watch count is only available on one of the tables. Now, when you have the same field name available on two parts of the tables, then you have to make sure you do not make this mistake of not, including the alias of the table you're selecting from. But best practices is to always put the alias anyways. So we then move to the next part. So we want to get the licenses from the license table, and then we say LIC dot license, right? And then here we have a complete query, right? And then when we run the tables, we basically get what we have gotten before, right? But there's a funny part here. Now, when we look at our answer, we notice something very interesting, right? So what we notice is that, we started from 400 K, in the sample repos, and we had even more rows in the licenses table. When we join these two, we notice that we even have less rows. So basically, because we're looking for the rows that are matching in the two tables, we now have a situation where we even have even lesser rows than we started with. Now, this is an indication that there's some data that is, in the first table. There's some data that is not available that basically is unique to different tables. So for instance, what it means is there's some data that is here. There's some repo names that is in the license table that is not in the sample repo tables, and vice versa as well. So this is the reason why we have even lesser rows, because we cannot match everything. So in the next class, we will see how we could use the different joins to basically satisfy different types of desires. So now we have our inner join and we can be happy. Welcome to this class. Now, in the last class, we did like the inner join, and we discovered that the two different tables, now the license table and then the sample repo tables, basically had some columns that were unique, that were not common to both of them, right? So in this class, we will look at how to use other types of join, particularly left join and right join, to take advantage of, basically to take advantage of this flexibility that is available in SQL to satisfy different types of desires. So assuming we basically have, basically on one side we have the repo name that has a watch count, and then on the other side we have some repo names that have a license. Now we want to have all the repo names that have a license, and maybe just as an added benefit, we would like to have, for those ones that have a license, if they have like a watch count, we would like to include it. But if they do not have a watch count, we would like to just leave it, right? So in this case, what we could do here is we just basically now identify. So what we want is we want all cases that have a license, but for the ones that do not have a license, we will like to keep, we will just like to for those ones that basically have a watch count, sorry, we would like to include it in our new data set. We would like to include the watch count field in our new data set. So in this case, what we can do is basically do like something that is like called a left join, right? So a left join will make sure that we have all the repo names from the license, and also we will have all the watch count that is available for this repo set included. And in the cases where it's not available, you have a null. So what do we do here? Maybe for this case, we could include the repo names for both of them. So basically we see like Sam. So sam.repo name, right? And then just to have some kind of consistency, I will include this here, right? So when we run this query, now something interesting is going to happen. So now notice how we call this left. So here, this is the left. The one on top is the left and the one below is the right. So what we are trying to say is we favor the left more than the right. Now, what we see here is when we try to join these two tables, we see that, for instance, we have some repo names that do not have a second repo name in the license table, in the sample table, right? So we do not see this data in the sample repo. However, because we have written a left join, it will still bring this case for the left side, which is basically the license. It will bring for every repo that has a license, you will see it. However, for those ones that don't have a watch count, you will just receive a null. And for the ones that have a watch count, that have a license, you will see them in this data set with a watch count. So what we see here now is we see a situation where some of them have, the full row. So this has like the first repo name, and because the repo name is found in the second table, you will also get a watch count. Now, if it's not found in the second table, you will not get a watch count. So in this type of situation, what is advised is you keep the repo name from the table that has the left side, the left join. And then maybe you can allow this to go. And basically what happens here now is you have cases where there is only null in the case of the watch count. And this basically tells us a story, right? It tells us that for the cases where you find null, you do not have the repo name in the sample repos table. So this is just, a way to pull this type of, data that, basically you're trying to get all the repos that have a license. And if these repos have a watch count, then you want to include it. And so you have some null cases, but you wouldn't have, you have some numbers in the cases where they have a watch count. Now, if we wanted to go the reverse direction, right? So the reverse direction means that we will basically use a right join. And when we do a right join, what happens is basically we favor the table on the right. Now, notice that I said this is the table on the left because, if we were to put it on the same line, we will have this on the left and we'll have this on the right. So basically, this means that if we want to favor the table on the right, then what happens is we will have all the tables that have a watch count, but we'll have the watch count. And for those ones that have a watch count, if they have a license, we will include the license. But if they do not have a license, we will have a null. Now, also, we have to put into mindset that because we are favoring this table to have all its data set, it's very important to have the repo name coming from this side of the data. And then when we run this query, for instance, what we get is this. So we will see that for all the cases where you find a license, you will get the license, right? So, but you get all the cases with a watch count. So all the table will have a watch count, but not all the table will have a license. So for some cases, we might see some nulls in the license. So maybe we can just scroll to the side and maybe we'll see some cases. So when we go to the last page, we can see that some of the cases actually have a watch count, but they do not have a license. So this is as a result of a right join. So we get every data that is available from the right side of the table, which is the watch count and the repo name. And then we get the one that is available from the license table, as a bonus. So this is what they call the right join. In this class, we have the opportunity to basically learn the full outer join. Now, what is the full outer join? Now, in the last classes, we noticed that we had played with the left join and then the right join. What the resultant of using the left join and the right join in the last class basically showed us that for data sets that it's not, when you use a left join, basically you have basically all the data from the left side and some of the data from the right side. And when you use a right join, it's basically the vice versa. You have all the data from the right side, but some of the data from the left side. So in cases where it is common. Now, in some cases, you might want to have all the data, right? So wherever it is common, you want to have it. And also the cases where it's not common on both sides, you want to have it. This is exactly the definition of the full outer join. So what is the full outer join? Basically, you put in this case, you remove the right join and then you put the full outer join. So now the full outer join is basically trying to have everything, right? And so because of that, it's also very important to have the two repo names here. So we put the license repo name here. And then we have all the data set. Now, basically, I could try to read the query again just to make us understand what we are trying to do. SQL is like a language, basically. It's a language, really. It's like English language. So when we read our query, it's very easy to understand and basically tell us if we have some kind of errors. So here we see we're selecting this license. We're selecting repo name from the license table and then repo name from the sample repos table and then license from the license table. And then we're basically selecting the watch count from the samples table. And everything is we're just basically selecting it from these two tables that has been joined with a full outer join command. And then we're joining on the name of the repo, right? So this is the idea. This is what it uses to match the two rows. In your Excel, it is joining, it's doing something that we will call a field lookup. So when we run these two data set, what we get now is a very huge data set, which basically is even going to be higher than this data set, right? So the highest data, this is the highest data set, which is the license, and it has 3.3 million rows. So what you would have here is now you have 3.5 million rows, or basically 3.6 million rows. Now, this table includes cases that is not available in the two, basically that is unique to the two tables, right? So it has the cases that is common to the two tables, and then also have cases that is unique to the two tables included. So what you notice as first is you have some cases where it is null here, and then you have a repo name here. So what it's telling us here in the case is this repo name exists in the license table, but it does not exist in the sample table. And that's why it doesn't have a repo name in the sample repo name area, and then it doesn't have a watch count. But this is a case where you have the data set in the both tables, because then you have a full row. So when we scroll down, we notice that, for this, early part of the table, we get everything that comes from the left. And then when we go to the last part of the table, we probably get, some cases where it's basically having data from the right side of the table, which is the sample repos, but we don't have this repo name. This repo name doesn't have a license. I mean, it is not included in the license table. And then this basically means that you have a null for the repo name, and also, the repo name from the license side, and also the license is not existent as well. So this is the idea of full outer join. Now, this is a beginner's level class. And so because of this, we will stop at this full outer join. However, there are some other joins that will be introduced in the intermediate course. And I would also like to say that you could join on multiple fields. Now, there are cases where you have to join on multiple fields because maybe these multiple fields are what basically matches the data. So, for instance, if, we have two tables that basically tells you the amount that I have in my account, for instance. And this is one table. And then we have another table that basically tells you the amount of food stuff that I have in my shelf. So basically, if you were to join this table based on my last name, you will basically have some issues because also maybe I share my last name with my junior sister, for instance. And to make some kind of variation, you might have to join on the last name and then the first name in this type of situation. So then you will be able to match for the specific person, you'll be able to match basically you'll be able to attribute the right row to the right person. You might also not want to use the first name because maybe I could have a namesake. But let's just assume that people do not have a complete namesake of first name and then the last name. And in this case, maybe my first name and last name together is unique. And so nobody else could basically bear my first name and last name. And in this case, you would have to join by making the first join. Maybe this is the first name, right? And then you will add an and then do the other join. Basically, you do not have to put the on again. You just include where it equals to. Now, this will be basically covered in the much more intermediate class, but for now, we will just take this as, the beginner's level, and we will develop with this on next classes. So thank you for being a part of this one. Thank you.